Right. Good evening, everyone. It's very good evening. Right, right. Right. Simple revision I'm giving here. We have taken PMMC, MI, EMMC. Right. Sir, in this errors are more. So errors are less. In this errors are less. Here, little bit more. In this, very high errors are there comparatively based on the given condition and all. Okay. Right. Now, sir, among these three, PMMC is applicable for DC, right? MI is applicable for DC and AC, and EMMC is applicable for DC and AC. Okay, sir. Here current and voltage. Here also, what is that? Current and voltage. Current and voltage. Here, current, voltage, power. Current, voltage, and power. This is a complete discussion regarding all types of construction operations, and it is applicable for which type of measurement and all we have taken. Okay, right. Sir, here in this DC current and voltage, DC current and DC current and voltage, which you prefer? Whichever the device has a less error, yes, it is preferred. This is not preferred, right? It is also not preferred, these two. And AC current and voltage, AC current and voltage, among these two, this is less error, this is more error. And DC power, AC power, right? So this is the total discussion we have taken in yesterday's class. Clear? And PMMC working principle, MI working principle also what I told you, the iron piece always moves towards lower reluctance path. Attraction is there towards the coil. Repulsion is there. Both will be moving, nothing but it is a fixed iron. It will be repelled from the iron piece. In the electromagnet moving coil instrument, two coils will be there. One coil is in series, one coil is in parallel. That is called as wattmeter operation. If both coils are coming in series in the circuit, ammeter operation. If both coils are coming in parallel in the entire circuit, called as voltmeter operation. But finally, we prefer for power measurement only. And in the EMMC instrument, main means always to the supply, L, load, and here one more is common. What does it mean by common? Current coil and potential coil, common point should be there. Why? Both must be connected in series and parallel respectively. And voltage. This is what the simple discussion we have taken. And we will solve the questions also. And here, the capacitance question, C is equal to epsilon A by D. This D I'm taking as X. But two plates are there like this. Two plates are there. But those are circular plates. Those are circular plates. Right? After that, area, what is the diameter of the plate is given as 8 mm. Distance between the plates is given as 4 mm during a measurement I told you. Right? Okay. After that, sir, here as the plates are moving, as the supply is given to the electrostatic instruments, the plates are moving, but the moving plate is moving means automatically distance between the plates will be changing. Distance between the plates will be getting changed. So therefore, what is that? Distance is variable. So dc by dx is equal to, what is the formula? Epsilon A minus 1 by x square. Clear? Right. What is epsilon? Epsilon not into epsilon r. But here, many people ask the doubt like, sir, what is area? Why you are divided with 4? Come on here. Area of the circular plate. Area of the circular plate. What is it here? Pi by 4 d square. Right? Otherwise, you can write pi r square. But he has given d now. So r is equal to pi d by 2 whole square. So therefore, pi d square by 4. That's what we have taken. And 1 by x square, but it is a distance. Based on this, and we have used one formula, fd is equal to half v square dc by dx. And one should ask that, sir, it is angular. No, angular means angular force, that is but torque, half v square dc by d theta. Very simple. In the third equation, either you take td into d theta or you take fd into dx. That depends on the linear motion or angular motion structure. That's what actual theory. fd equal to half v square dc by dx. Otherwise, half v square dc by d theta. Anything you can use. Right. Here, sir, this is the instrument REM, right? In the PMMC. Or in the MI instrument, REM and LM. This is REM, this is LM. Already, this is the instrument constructed by the manufacturer. Already, this is the instrument constructed by the manufacturer. Okay. I'm giving extension. What is extension? Like this. I'm connecting one R. Ammeter extension, for example. This R as such should be made up of what I told you, manganese or constant, I told you, generally. Okay. And this is generally winding is made up of copper. People's doubt here is, sir, two are different materials, so that effect will not be there, effect will be there. Concentrate here. This is already designed. Our duty is not to disturb this entire structure. Our duty is not to disturb this entire structure. Our duty is to extend the range without disturbing this. That's why whatever the element we are placing for extension should not disturb the instrument structure. Means should not get disturbed with the temperature. If it is getting disturbed with the temperature, for example, copper I'm taking. Copper resistance is not fixed, varying with the temperature. As it is keep on varying, the current division will be varied. Therefore, its operation performance, everything will be disturbed. That's why be clear. Here, two different metals are one metal. That is not the matter. It is already there. Whatever the material we are using for extension, either parallel or series, anything based on the ammeter and voltmeter, that should not dependent on temperature changes. Therefore, it will be constant. So therefore, it will not affect this entire thing. That is what our task actually. And a few people ask that, sir, here, sir, this is which device? 0 to 1 ampere device. In this, REM is there. Okay, right, sir. I'm using this resistance RSH, and I can say that 0 to 10 ampere. People are still asking that, sir, scale is changed from 0 to 1 to 0 to 10. Is it? Are you changing its scale? No, this is only calculation process. This is only calculation process, but not the instrument construction chain. First of all, tell me, as the operator, right, do you change the scale of the device? Do you change the construction of the device? That is the reason why we are not changing the scale. I told you here, before extension or after extension, instrument scale will be same. Only instrument measuring capacity will be increased. That too mathematically. In the instrument, see, by seeing this instrument, you cannot observe 5, 5.5 or 6.5 like that. No, you will observe less than 1 only. But I told no, by using the formula, you are going to obtain this. This is only calculation process. Calculation also measurement process only. So this is the total topic revision, all types of instruments, and we have taken questions also. And one more doubt is also there. Generally, sir, ZSH is equal to Zm by m minus 1. ZSH is equal to Zm by m minus 1, right? RSH is equal to Rm by m minus 1. This is we have got. From this, similarly, I have written. Yes or no? From this, what we can write? RSH plus JXLSH. Zm ante, what do you mean by Zm? Rm plus JXLM. Suppose in the given data, XL is not given, no problem. You can erase this simply. What will become here? R. That's why according to the given data, you have to take it. And one more question I gave you for just for practice purpose in yesterday's question I gave you, sir, I have simplified with I calculation. One question remembered. After that, what is it? RESC calculation, V by something. We have got answer as 2511. Okay. I gave one other method of practice. What is that? ZSE is equal to Zm into m minus 1. What is Zm? Right? Rem plus JXLM. Right? M minus 1. M is 500 by 250 minus 1. You'll be getting ZSE magnitude only. Angle, no, don't worry. Magnitude you'll be getting. After that, I told you, kindly use common thing. This is a simple point. What is that? Sir, C is equal to 0.41 Lm by RSC square. After that, what I gave you? ZSC is equal to R and C parallel, right? RSC by 1 plus J omega RSCC. Few people ask that, sir, by using this formula, can we proceed? And we can proceed, but this is what very important. That's why in this RSC here 0.41 Lm is given as 0.6, I think, right? And then 2511. After that, you will get some micro or picofarad something. After that, in this ZSC, this value is there, substitute. RSC value is there, substitute. C value substitute, then you will get left hand and right hand. This is a common sense, minimum common sense. Then what do you mean by that? Simply, okay, one equation, two values are unknown. How can you say that proceed? One should ask yesterday. This is what, as the two unknowns are there, that's why I did not use this. But after this procedure, we know RSC. That's why we can substitute in this. We can compare RSC and C combination. RSC, find out the C and then RSC function. Clear? Right. What you are saying now? Suppose if I say count it. Suppose unknowingly, if anyone faculty says that count it, so how can you count it? It is calculate now, but you said that count it. You should not. In this way also 2-3 members are pointing out, right? If I say find it out, so how can you find it out here? Sir, we need to count it now. In that way, people are asking, right? So no problem here. In this, Procedure I gave you already. Procedure I gave you already. After that, substitute this RAC and the C value will be there. By using those two, left hand side, right hand side, same. Yes, automatically our answer is correct only. But in this process, he is not asking ZSC. See, people gave this as 2507. ZSC is 2507. But what we require? RESC means ZSC 2507. RSC 2511 means difference is there, means capacitance is there. That's why I told you to verify with this. That's what the point. Right? So this is a total revision. Every day before starting the today's topic, I'm completely revising the topic. Just brush up, kindly prepare well and come back. Right. So did you told how DC average value measured by MI? If you are giving DC, if you're giving DC itself is average value. You are missing small thing here. DC itself is, so this is 5 ampere, for example. What is its average value? 5. What is its instantaneous value? 5. What is its RMS value? 5. What is its maximum value? 5. But network theory, I think it is over. Even though if it's not done, no problem. In the DC, whatever the magnitude is there, one name should be given. No, that name is average word we use. That's why average word and RMS word, be clear. In the DC, we don't define RMS. Why? Only one value is there. What is that value? Peak value. Everywhere same peak value. Everywhere, if we find out average also, same thing. Everywhere same instantaneous value. That's why DC means itself is average. DC means itself is average. AC means RMS, average, maximum, instantaneous will be there. But if I'm talking about just magnitude 230 volt AC, then we should say that is RMS. That's what the point. Clear? So this is the total discussion regarding entire topic of earlier days. Complete revision. Just I gave small version. Right? Okay. One example. See, MI instrument is connected to DC of 5 amperes. What is the MI instrument reading? In my question itself, his answer is there. DC 5 amperes you are giving. MI gives which value? 5 amperes only. IDC given as 5 amperes. DC average value is 5 amperes only. Mathematically. But strictly speaking, after our entire explanation, conclusion, everything you have taken now, for DC, do you prefer practically MI? No, because PMMC is best instrument, less errors, but numerically we can solve it. And MI, for example, what is that? AC supply I'm giving. AC supply I'm giving. What is that? 8 sine omega t, something is given, right? Then what is the MI instrument reading? What is the MI instrument reading? What is that? I equal to Im sine omega t. MI instrument reading is IRMS. What is IRMS formula? Im by root 2. So therefore, 8 by root 2. We have taken so many times. We have taken. Right? Karthik, you have given 5. For which one? Okay, first question, correct. Saukya, kindly check it. It is not 8 here. 8 is maximum value. I is equal to Im sine omega t. So Im by root 2 will be there. Suppose, let me give one more example. Sir, I of t equal to, same question, minus 8 plus 6 root 2 sine 314t is given to Mi. So what is the reading? So what is the reading? Mi instrument reads RMS value, IRMS. What is the IRMS formula? Root of whatever the constant value is there, square plus less. What about this value? Maximum by root 2 square. This is the electrical basic point from the network theory. I'm getting the, I'm using the same formula. Okay. So okay, right. Sri Vidya, you have given 6. Can you check it? Right, Venkana, correct. Triangular sawtooth, Im by root 3. Very good. RMS value. Right. 10 is the answer. So simply, what is that? 10 ampere. That's what the point. What you are giving? AC. AC you are giving means indirectly RMS value will you give, but equation point of view, instantaneous you are keeping. That's it. Right. Dinesh. Right. Wherever the shortcuts are possible, I'm giving, but in the starting only I told you measurement subject is conceptual subject. Conceptual subject means to get the concept, no shortcuts. To get the concept, no shortcut. But whenever the numerical questions are there like this, I will give you the shortcut. Right? For see, every subject should not be studied, should not be read for only marks. No, few subjects will be getting the score, few subjects will be getting the core knowledge. That is what? Measurement, conceptual subject. Right. Sir, once you told it oscillates around 8 amperes, what is it? That is PMMC, but this is which device here? Or what is it? MI instrument. MI instrument. This is AC only. AC RMS only example. People are giving that. So give me one example of AC RMS. This is AC supply only. Yeah? AC supply only. And here I gave you already one more pure sinusoidal wave RMS value and a combination of DC and AC combination, but completely AC only RMS value we have taken. Right? Suppose if any question is given, like suppose actually will not be given a 230 volt, a 230 volt AC is given to MI instrument, then its reading in the question itself is answer is there. What is it? MI instrument reads RMS value directly 230 volt. What is this 230? What is 230 here? Vm sine 314t V of t, right? In this, from this Vm by root 2, if you take, you will get 230. That 230 is our this one. In our house, 230 volt supply we say. 230 volt supply you say. What do you mean by that? 230 RMS value only. That's what the point. Yes, direct answer. Right, one more. Jadhav Pradeep, today I have received the material from AS. Very good, very good. Happy. Kindly practice. Practice in the total material. Two volumes will be there. One is volume 1, volume 2. One is workbook and one is self-practice book will be there. Workbook means sorry, textbook means I am going to solve all the questions. Self-practice booklet will be there. You need to practice. Those who have received the material. Okay. Otherwise, yes, follow the material until you get that. Right now, let us start the topic. Right. Yugasri, 230 by root 2 will not be taken, sir. 230 by root 2 will be taken only when if it is mentioned as maximum. All I told you, if it is not mentioned, that is not called as maximum. Automatically RMS only. Automatically RMS only. Right? That's why in the electrical basics only, in the AC 230, if any 230 is given RMS. In our house, 5 amperes of AC is there, RMS only. That's why if nothing is mentioned, automatically, directly which one here? RMS value only. Right. DR meter syllabus is not there, that is galvanometer, leave it. Whatever I have completed in the class, kindly go through those only. Our available power itself is average power only. Suppose in our house we are consuming 2 kilowatts. Kindly concentrate. This is the electrical basic point, but many people are having this doubt generally. Common doubt. This is a very common doubt with electrical and IN people. In my house, I am consuming 1 kilowatt of power. What is that 1 kilowatt? That 1 kilowatt is average power only. That is what? VRMS, IRMS, cos phi. That's why don't worry. How the EMMC reads average power means available power itself is average. Available power itself is average. Clear? Tulasi, which question? Right. Average and active both are same. See, that is different representation. I'm going to take now. I'm going to take now. Right. Why this? Amit Vikram Pujar. Network theory completed for you? Network theory completed, Amit Vikram? Network theory completed, Amit Vikram? No, sir, not yet. Yes, you will get that point later. You will get that point later. Right. I'm covering both GATE and ESC, all types of PSUs. Don't worry, don't worry. It is covering both. RMS power is not there, not there. Okay. Right. See, 230 volt maximum value. 230 volt maximum value is given to MI instrument. Then its reading is MI instrument reading is, try to listen the statement. Already almost 10-15 times I revised. 250 volt maximum value is given to which one? 250 volt AC maximum value is given to MI. MI reads, first of all, MI instrument reads which value? RMS value when AC is given. What is the VRMS formula? V maximum by root 2. What is V maximum? 230 by root 2. This is what the answer. Suppose in the question, 230 volt AC is given to, actually question will not be asked like this, but people are asking, sir, MI instrument reads which value? MI instrument reads VRMS. What is VRMS? So directly 230 volt. That's why terminology maximum is given, then only it is maximum. Maximum is not given, AC means that is RMS value of current or RMS value of voltage only. Yes, 230 by root 2. Very good, very good. Many people do that. Correct. Okay, very good, very good. Right. Now I'm starting the topic, today's topic, that is measurement of power. In that, the first topic is which power? DC power. Right. Almost 8 days are over. At least day by day, change your habit of asking the questions while the topic is going on without listening the topic. I'm requesting everyone. DC power. So what is the DC power? P average is equal to V average into I average. This is general formula. Okay. What method I told you? PMMC, voltmeter and ammeter method is there, I told you. Yes. Very popular one. I'm repeatedly saying here, GATE and ESC prelims both will be covered. That's why topic to topic I'm saying. This is the conceptual question in the ESC, and numerical question is common for both GATE as well as ESC. Right? Right, sir. In this voltmeter and ammeter method, right? Okay. Now I'm taking first method as VA method, second method as AV method, VA method and AV method. Okay, right, sir. Here some load is there. Some load. What is the power consumed by the load? That's what our task. Okay, DC power measurement. Here also some load is there. Means supply is given to the load. Corresponding power will be consumed by the load. Right, sir. Which devices? PMMC devices. PMMC devices only we are measuring. We are using. Okay. How I'm connecting? First I'm connecting voltmeter here, and second I'm connecting ammeter here. Second I'm connecting ammeter like this. Right. Now PMMC voltmeter reads which value? V average. PMMC ammeter reads which value? I average. Sir, V average into I average. Yes, power. That's what the actual topic. Okay. In this case, how I'm connecting? You know, first ammeter, then voltmeter. Like this, I'm connecting. Clear? Now, first of all, in order to proceed, don't answer. I'll question, I'll answer. In order to proceed, the people are asking that, sir, this is correct, this is wrong, connection, or this is correct, this is wrong, they are saying. First of all, how to decide with which is correct and which is wrong? Be clear. Voltmeter should be in parallel, correct. Voltmeter should be in parallel, correct. Ammeter should be in series, correct. Ammeter should be in series, correct. Therefore, both are connection wise, both are correct. First point. That's why people are asking, sir, which is correct? Both are correct only. We are analyzing now. This is better for which operations? This is better for which operation? That is what our conclusion. Therefore, both connections are valid because I'm repeating, ammeter is in series in the circuit, Voltmeter is in parallel in the circuit, voltmeter is in parallel in the circuit. Nice. Mallesh, I told you, don't type anything. Don't type anything. Okay, next. We are measuring means practical only. All these are practical. No need to mention if it is not ideal, it is practical only. If it is ideal, I will mention. If it is ideal, I will mention. Okay, right. Sir, first one. Sir, what is the true power consumed by the load? We don't know. Mathematically, we don't know. But terminology wise, across the load, VL. Across the load, VL. Across the load, VL. Some load. Is a load voltage is VL. Terminology I'm taking. So through the load, current is IL. Through the load, current is IL. Okay. We don't know VL, we don't know IL magnitude. If you know VL and IL magnitude, no need to go for this measurement. That's why terminology I'm taking. That's it. So what is the true power consumed by the load? Voltage across the load VL, current through the load IL. Here also, voltage across the load VL, current through the load IL. Okay, right now, but we don't know this. Now we are going for power measured. So how we are measuring the power? We are measuring the power by voltmeter and ammeter, not by wattmeter, in this method, because wattmeter already we have seen. Yesterday only we have seen wattmeter method of what is it? Correspondingly. Right. Here, right. The question is power measured. How we are measuring the power? You know, voltmeter reading into ammeter reading. In a laboratory, this only we do generally. Voltmeter, ammeter, by multiplying those two, you'll be getting this value. Same thing here also. Voltmeter reading into ammeter reading. Voltmeter reading into ammeter reading multiplied. Okay, sir. What is the voltmeter reading in first connection? Keenly observe the circuit. Sir, voltmeter connected over here. Voltmeter connected over here. Okay, this voltmeter reads which value? This voltmeter reads which value? Means here voltage across these means voltage across this entire thing will be read by the meter. Why? This is connected across this means these two combinedly coming across the voltmeter. That's why voltmeter reads which value, guys? VL, and voltage across the ammeter. We don't know the terminology I'm taking. VA. So therefore, voltmeter reads VL plus VA. VL plus VA. Immediately don't say error is there. Practically measurement error will be there. Error should be there. Our analysis should be minimizing the error. I'll tell you. Okay. Right. Come to this. Sir, in this circuit, voltmeter reads, sir, voltmeter is directly across the load. What is voltage across the load? VL. So therefore, what is it? Only VL. Okay, right, sir. In this case, in the first case, ammeter reads which value? Sir, ammeter reading current, same current. Which current? Current through the ammeter and load, both will be same. So therefore, IL. Okay, but here, sir, current through the ammeter. At this point, divided into IL and IV. So therefore, current through the ammeter is the combination of IL and IV. Combination of IL and IV. This was the observation. If you understand this, the thing will be done simple mathematics only. That's why I'm repeating again. Concentrate here. Concentrate, sir. Voltmeter is connected across these two. That's why VL plus VA. Okay, voltmeter is connected across load directly. So therefore, what is that? VL directly. And current is directly in series with the load. So IL only. But current is here. Ammeter current is sum of these two currents, IL plus IV. Okay, now let us proceed with the mathematics. Right now, what is method? VA method. So what is it? VA method. AV method. VA and AV method. Okay. So in this, what is the formula we have got? Power measured is equal to, what is it? I'm writing this point again. Simply VL IL plus VA IL. I multiplied VL IL, VA IL. In the same way, power measured is equal to VL IL plus VL IV. Check it here. VL IL plus VL IV. That only you have taken. Now check it, sir. What is VLIL? Sir, VLIL is true power. Sir, VLIL is true power. Therefore, sir, power true plus VAIL. Here also, power true plus VLIV. Okay, right, sir. From this, what we can say? PM equal to PT plus something. PT plus something. So therefore, what is it here? Which is more? PM is greater than PT. Here also, PM is greater than PT. Complete topic itself is mathematically conceptual. Let's be clear. I'm coming again. PT plus something. PT plus something means more than PT. Yes, PM is greater than PT. PT plus something, yes. And the two people are asking, sir, if VA is negative, IL is negative, these are only magnitudes. These are only magnitudes. Negative indicates only direction in the reverse way. That's why magnitudes means directly greater. Sir, what will be the error now? What will be the error now? Sir, error is positive or negative. Sir, AM is greater than 80. Error is positive. AM is greater than 80. Error is positive. Clear? Right. Sir, one more thing here. What is the error formula? Error formula is PM minus PT. Generally, AM minus it is power. No, PM minus PT. Here also, error is equal to PM minus PT. Okay, right, sir. What is PM minus PT? VAIL. What is PM minus PT? VLIV. Therefore, I'm writing now. Error is equal to, sir, IL as it is, I'm writing. What is VA? Check it here. Sir, voltage across the ammeter, general formula, voltage across the ammeter is equal to current through the ammeter into resistance of ammeter. We don't know, terminology only, right? Current through the ammeter into resistance of the ammeter. What is current through the ammeter? IL into RH. Check it here. Ammeter reading IL. No. So therefore, current through the ammeter is IL. Resistance is RA. So therefore, IL into RA. Therefore, what we can write here? Error is equal to IL square RA. Right? In VA method, error is there. That value IL square RA. Okay. In the same way, sir. Therefore, error is equal to VL into. Sir, what is IV? Check it here, sir. IV means current through the voltmeter. Concentrate, guys. current through the voltmeter. So what is the current through the voltmeter? Voltage across the voltmeter. What voltage voltmeter? VL. So therefore, VL by resistance of the voltmeter, RV. Terminology only. RV. VL by RV. VL by RV. Right? Now, sir, therefore, error is equal to what is it? VL square by RV. And concentrate here. And I told you in yesterday's class, errors are because of friction, because of temperature. Temperature means heat, because of frequency, because of hysteresis, and because of stream magnetic error will be there. That is conceptual. But I told you here, VA and AV means connection based. Therefore, in this connection, this is the error. Okay. In this connection, this is the error. So therefore, our topic is VA and AV method means connection based only. Other than that, temperature errors, frictional errors, everything is common. But our numerical based error is which one? Connection based error only. Try to understand the topic. What is that? Heading only gave you the power. DC power can be measured by voltmeter and ammeter with two different connections. I told you VA connection, AV connection. With two different connections, it is possible. VA and AV connection. That's why this error is due to the connection of voltmeter and ammeter in VA method. This is the error in AV connection method. That's why our topic is connection based only. Sir, what about other errors? Already we have taken the yesterday's discussion. Yes or no? Those errors are generally present. In the question, those are given, add them. Those are not given, neglect it. Based on the question, you need to proceed. Okay? Now, let us proceed further. Not completed here, only half of the data is completed. Now, very, very, very important conclusion I'm giving. Kindly I'm requesting to concentrate more and more on the terminology now. So far I have taken simple mathematics only. VA and AV, circuit based connection you have taken simple mathematics. Okay. Now the question here is, sir, what is the percentage error formula? What is that? PM minus PT by PT into 100. Percentage error. PM minus PT by PT into 100, general formula, you know, right? Sir, what is PM minus PT? Check it. PM minus PT is IL square RA. You can write VAIL as you wish. I'm writing this. So therefore, IL square RA by VL IL into 100. That is percentage error. So this is the formula for percentage error calculation in VA method. Okay. Now here percentage error PM minus PT. What is that? VL square by RV. Check it here. VL square by RV. True power is VL IL only. So therefore by VL IL into 100. Like this. Okay. Now the conclusion is, sir, in both the methods error is there. In both methods error is there. Sir, which is best then? Which is best? Means VA method error is there. AV method error is there. Sir, which is best? Both are equally good at their own condition. What is that condition? In order to answer that, sir, in this method error is due to. In this VA method error is due to dash. I'm finding. I'll give you. In this method error is due to dash. Sir, concentrate. What is error value? IL square RA. Everyone listen carefully. IL square RA is the error magnitude is clear. Okay, but this is the error magnitude due to which device, due to which parameter that we are concentrating now. Sir, RA means ammeter resistance. Obviously, measuring device definitely gives error, but less error only. Gives error definitely. So therefore, RA is due to ammeter. So therefore, error is due to ammeter. Okay. So what about IL? IL is also, check it here. Sir, current through the ammeter IL is coming over here. Yes or no? Concentrate here. Here, IL, IL, IL is coming over here. So therefore, current through the ammeter is IL. That's why what we can say, error is due to current through the ammeter, resistance of ammeter. I'm coming again. Error is due to these two parameters. One is current through the ammeter, other one is resistance of the ammeter. That's why error is due to ammeter. That's what the point. Error is due to which device here? Ammeter. Okay. Again, people are asking, sir, both meters are there. Both should give the error. Be clear. It also has temperature, frictional, hysteresis. All types of errors will be there. But in this connection, the connection-based error is due to ammeter. Sir, how? Completely mathematically proved here. So therefore, what is it? Error due to ammeter. Error due to ammeter resistance. Error due to current through the ammeter. Finally, error is due to ammeter. Okay. Immediately, people are, if I ask the question like, how do you minimize this error? Sir, error is due to the ammeter. Yes. How do you minimize this error? Means people are saying that, sir, remove the ammeter. Come on. If you remove the ammeter, do you have power measurement? No. Means our power measurement must be continued, but error must be minimized. How? I'll tell you later. Next point is on. Next, coming to this. Sir, error is due to dash in the AV method. Check it. Sir, error is this. RV. What is RV? Voltmeter internal. Of course, voltmeter will give the error. Yes, voltmeter resistance. Okay. Right. Sir, error is due to voltmeter resistance. Okay, common. So what is VL? What is VL? You know, sir, VL applied across the voltmeter also. Load voltage, voltmeter also. So therefore, what we can write now? Sir, error is due to voltage across the voltmeter, resistance of the voltmeter. I'm coming again. Error is due to voltage across the voltmeter and resistance of the voltmeter. Are you clear? So therefore, error is due to voltmeter. Okay, sir. In both the methods, error is due to dash. Means meter. In VA, yes, very good. You guys are correct. VA method error is due to ammeter. AV method error is due to voltmeter. Yes, very good. Very good. Right. Clear, guys? Right. See, Vamshi, can't we connect one after the other? What do you mean by one after the other? I'm connecting one after the other only. First this, second this. First this, second this. I have connected one after the other only. Okay, come back. Sir, in this case, error is there. In this case, error is due to ammeter. In this case also error is there, but due to voltmeter. Again, come on. So two methods are there. Two methods, error is there. In two methods, one device is the error. Okay, but sir, I want to prefer VA method. When should I say like this? I want to prefer VA method. When should I this means? In VA method, if this error value is less, then we can say less error is there. Less error is there means VA method we can prefer. VA method we can prefer, like that we can say. So that's why at which condition? Be clear. What I'm waiting, you know. Suitable for nothing but what? Preferable for, we can say. Suitable for or preferable for, we can say. So that is what, sir, I prefer VA method when error is less. This error. I prefer AV method when this error is very simple. So that's why, what is the logic here? No, sir, VA method, this error must be low. Sir, when it is possible. Sir, this entire thing must be low. Means individually let us verify. RA must be low. Sir, RA already low. Why? RA is given by which owner? Manufacturer. In the ammeter, resistance will be already low only. Therefore, in the ammeter, whatever the ammeter we are receiving from the manufacturer, already designed with which one here? Low resistance. Already designed with low resistance. So therefore, what is the point now? Here, this is low only. Yes, it is already low. No problem. Sir, in order to say error as low, RA must be low. Already RA is low. Already RA is low. No problem. We need not to worry about it. Sir, what else must be low? IL also must be low. IL also must be low. Sir, how do you say that? When do you say that? When do you say that IL must be low? Means concentrate. Here, IL must be low means, sir, the load should offer high resistance or low resistance. Means if the load is offering high resistance, current through the load will be less. So therefore, high resistive load. If high resistive load is there, IL will be low. If IL is low and RA is already low, error is also low. Happy. That's why VA method is suitable for which one here? Low current application, nothing but high resistance load applications. Therefore, suitable for high R loads, or we can say low current loads. High R loads, or we can say low current loads. Means if I give you high resistive load or low current load, automatically you have to prefer which method here? VA method only. VA method only. Next, coming to this. Sir, in order to prefer this method, which one? This error must be low. Sir, in order to have less error, denominator must be high. Obviously, right? It must be low means denominator must be high. Sir, RV must be high. RV must be high. Come on here. Voltmeter resistance is already high by the manufacturer. So no need to worry about this. Or it is high only. Which is there now? So this is the numerator. So no. Therefore, VL must be as low as possible. VL must be as low as possible. Means VL must be as minimum as possible when it is possible. Now check it here. Sir, VL must be as low as possible. Isn't it? When it is possible, the load should offer less resistance. Less resistance, less drop, that is less voltage drop. That's why what we can say, less resistance means suitable for low R loads. Suitable for low R loads. Sir, resistance is low. Automatically, what we can say, high current. Suitable for low R loads. Otherwise, high current loads. Okay. Now, be clear, guys. Question itself is given that concentrate. Here, this is R1, this is R2, voltmeter and ammeter. Both devices given to you. I am mentioning the question says that yes, measure the power consumed by this high resistive load. Everyone kindly keenly observe the question. How do they ask and how should they ask? Here, take this high resistive load and measure the power consumed by this load by using voltmeter and ammeter. In which connection you have to prefer? High resistive load means VA connection. If I say the question like, take this low resistive load, take this low resistive load and measure the power consumed by this load in the given circuit condition, low resistive, which method here? AV method. Immediately people are asking that, sir, if high and low is not given, question itself is high and low. If it is not given, question is not there. Simple. Sir, people are asking like this. So find out the R total if I ask the question. Do you get any question like, sir, if R values are not given, how do you determine? Do you get this question in the other subjects? No, but in the measurement, generally, this doubt will be there because the question formation is like that. What we say? If I give you high resistive load, immediately you will get the doubt like, sir, high word is not mentioned. Question will be there. That's why I'm asking. Take this circuit and find out the R total. Means every one of you took the circuit, calculated the R. But did you ask the question like, sir, if the circuit is not given? Happy. No question, no answer. Relax. Question is not given. No need to answer. No need to bother about it. Are you getting my point or not? That's why that is what the question. Take this circuit means immediately the circuit is not given. Come on. Circuit is to be given to answer. Otherwise, happy. No exam, no question, nothing. Clear? So that's why this is the question given. Okay, people are asking that, sir, if the medium resistance is given, consider which will be called as medium. There is no particular number. That's why the question will be like higher side resistance and lower side resistance only. They will mention, yes, high resistive load VA method. No, that's why both are equally good at their own condition of high resistive load and low resistive load. Both are giving less error only. Both are giving less error only. Clear? Right. Jadhav Pradeep, the circuit name itself is VA method, not one after the other. VA method means combination. We need to go for combination only. Combination only. Right. What is the value of high resistance? Yes, wait, kindly. Resistance measurement is there. I will tell you high resistance value. What is that, etc. I'll tell you in the bridges. Lengthy chapter is almost 6 to 7, 8 hours topic is there. Yes, definitely. Right. Sunil Wagmer, don't question like, sir, questions. Sir, take one example. I will take the example, right? 8 days are over. You need to understand how I'm explaining. After the concept related to that numerical question will be there. Wait until that. And people are asking, Lakshmi Kiran, people are asking, sir, why not wattmeter? I told you already in the yesterday's discussion, wattmeter is already there. We have taken in the yesterday's class wattmeter already. Other than the wattmeter, if I give you voltmeter and ammeter also, do you measure? Means can you measure or not? Yes, measure. That's what the point. I'm not saying that don't use a wattmeter. No. Suppose with your wattmeter is not there, DC power is to be measured, then PMMC voltmeter ammeter used or not, yes, you can use and you can find it. That's what the point. Okay, finally, correct. Finally, what people are asking, finally, sir, either VA or AV, how do you get or when do we get same error? In both the methods, I want to get same error when it is possible, means concentrate. Condition for same error in both VA and AV methods. Condition for same error in both VA and AV methods. What is the condition? The point here is condition for same error in both VA and AV method. What is that? Means, sir, in the VA, suppose error is 1%. AV also I should get same 1%. So how is it possible? This is suitable for high resistive load. High resistance, if you are using high resistance, error will be low. Is it no? This is suitable for low resistance, error will be low. How can you say same error? Means I'm taking, sir, here VA method. AV method. Okay, VA method. What is the error? IL square. VA method and AV method errors you need to equate. That's it. What is VA? IL square RA. AV error VL square by RA. Sir, I'm bringing here VL by IL whole square is equal to, what is it? RA into RA. So VL by IL, what is it? VL by IL. VL by IL, what is it? RL, load resistance, voltage by current resistance. So therefore, what is it? RL is equal to square this side, root of RA into RB. Right? Means if the load resistance is equal to root of ammeter resistance and voltmeter resistance, for example, at that condition, either VA or AV, no problem. In both the cases, you will get the same error. Based on this also, questions are there and we are going to solve as many as possible questions. Very good, Nupin, correct. This is what the complete discussion on VA and AV method of power measurement. Which one? DC power measurement, because PMMC, V average and I average topic. Right? Okay, sir. In your laboratory, now I'm asking the question. In your lab, I don't know you remember or not, but it's practical question. VA method you prefer or AV method you prefer? In your laboratory, while you are measuring the power. Which method you prefer? Kindly let me know. Now you need to answer. Okay, we did not do the experiment. Very good. No problem. Okay, people are giving VA and AV, both you are giving. Few people VA, few people AV. AV, sir. Okay, few people VA, few people AV method. Okay, okay, okay. Okay, very good. Ramachandra Kashyap. Sir, both we have done, but at that time preference we don't know, sir. Yes, clarity based answer. Very good. That's what. In machines experiment, AV method you followed. Okay, right. Now I'm giving the answer. Concentrate. See, in your laboratory, very big box will be there. Some wheels will be there. If the faculty is not there, you pushed here to there to here. You played no. So that type of load I'm asking. Right? In that, so many switches will be there. Like DP/DT switches are nowadays automatic switches are coming. If I keep on adding that resistance, so this is resistive load, for example, resistive load. This load is given to A batch, same load is given to B batch, same load is given to C batch in the laboratory, same load is given to D batch, for example. Okay, one student, one batch, right, connected AV method, one batch connected VA method, one batch connected VAV method, other batch also connected AV method, for example. Definitely result will be different or same. Different only. Why? Same load, few people are connecting AV, few people are connecting VA method. Different result will be different only, obviously. Okay, but first you have to understand, few people are message that, sir, in our laboratory, I used AV method only, sir, because in our laboratory R is low. No, yeah. In your laboratory, R is high. Our application is low current application. Suppose if you say low resistance means high current. In the college laboratory, is it high current application? No. In the entire machines laboratory, the maximum current you operated is 13 amperes. The two 13 amperes is the maximally you have operated, that's it. So that's why that is not the, what is that, high current, that is low current application. In the industries, high current and low current both will be there, but in our college laboratory, what is that here, low current application. That's why huge amount of resistance is to be taken, because precautions must be not that much highly standard. What we wear maximum to maximum, shoe and rubber mat, nothing more than that. Gloves also we don't wear. So much of precautions are not there. Safety precaution. That's why college laboratory itself is safety point of view. Low current application only. Low current application only. Be clear. But don't think like people give that, sir, in my laboratory, AV, sir, low resistance. No, yeah, in your answer, low resistance means, okay, it is consuming more current, high current. No, not 20, 30, 40, 100 amperes will not be there. But the laboratory, both will be there. High current will be there, low current also will be there. But so few people told that, sir, we used both methods. That's why I told you. For the same load, A batch only, for example, VA and AV. I don't know this is done or not. Like this, we conduct the experiment and we compare these two, in which case error is less, in which case error is more. That we have to compare. That is common. But I am asking that, not comparison in the measurement lab, in the machines laboratory, if the power measurement by the corresponding load is to be measured, definitely you have to use VA method only, because in the laboratory, definitely high resistive load, that to college laboratory, not industrial laboratory, college laboratory, what is it? Low current applications only. Otherwise, hazardous will be there, so safety will not be there. But here I want to give something. Suppose here, this B batch, assume that in your college generally toppers batch like that, you'll comment your friends, right? Topper batch and all. Okay, assume that this is the topper batch, for example. Toppers batch, for example. After seeing the entire result, what faculty says, this answer is wrong, this answer is wrong, this answer is wrong, this answer is correct. Immediately, these ACB, ACD batches will think like, they are topper, whatever they say, whatever they do, the faculty is saying correct only. This is general thing happened in the college. Actually, it is not the matter of toppers batch or normal batch. It is a matter of connection. Yes or no? You are taking high resistance and you are giving that as a result. Is it acceptable? No. Why? Check it here. Sir, high resistance is there. AV method. A, C, D. 3 batch people conducted the experiment with high resistance load. AV method. Now go back. Sir, in the AV method, what is it here? High resistance load is connected here. In the AV method, high resistance load. Check it here. Sir, error. Resistance is high. Resistance is high. VL will be high. VL is high. Error will be high. Obviously, error is high means answer is wrong only. It is not the matter of X person or Y person or top or not. No. Simply it is matter of which load you are using. That is what the actual thing. Are you clear? Right. Dinesh, thank you. So this is generally it is what happens. So many problems will be in our laboratory. See, one more thing also I'll tell you. Generally, kindly don't mind those who are girls on the line. Kindly don't mind. Practical scenario. What I observed, I'm saying. I have seen so many cases. Girls, I have seen here. Not everyone I'm pointing out. Don't take it to heart. I have seen many of the cases. 5 members will be there in our generally college laboratory. 1, 2, 3, 4, 5 members in one batch. Right? One girl is suppose is there. Always taking the notebook and writing. Only. Mostly, only 1 or 2 people will be there. They will come in forward and they will connect it. Okay, one thing, sir. If you're sitting and writing, how do you get the experiments? Is it no? If I shout at them, they will cry. Unnecessary nuisance. That's why we don't say anything. Immediately we'll say that favor to the girls. What is this? All these things will be happen in the laboratory. If you scold them, problem will be there. If you don't scold them, favoritism. Come on. So that's why it is not the matter of all those. If we scold them, what is it? Okay, as a student, you should also do the experiment. Then only you will get the subject. Otherwise, no use at all. Finally, what we say? Electrical branch is waste. No future, nothing. Electrical branch, life is not there. Future is not there. Come on here. Come on. That's what. Kindly utilize the thing. Okay, if anyone is pursuing, kindly, you need to even see. Not everyone here. Of course, bias also there. 4 members means 2-3% will be there. Always roaming in the laboratory. Always the faculty is coming to the near to the batch. Values are over. Okay, he will copy only. Everywhere, boys and girls equally there. But why I'm pointing out means to need to understand that. You need to understand that. That's why I'm requesting everyone. Already, I'm openly saying, don't worry. Our education system is olden day system. Generally, not updated. Still, we are not attending those laboratory properly. That too, 99% of the people, I can give the guarantee, attend the lab session for 3 hours attendance. Especially. Okay, 3 hours attendance. They will count it. Okay, Monday lab is there. Okay, Tuesday lab is not there. We can bunk the college. That's what the thing. Kindly don't do that. If you would have done all the missions laboratory experiments and measurements or etc., all the lab experiment seriously, sincerely, this entire explanation will be just like a revision. But one student to give obediently, sir, I did not do the experiment. Yes, because so many colleges are like that only. Nowadays, so many colleges, people are not doing the experiment here. Lab assistant will be connecting the entire circuit. He will say that, okay, he will move the rheostat or take the reading, note it down. Batch is over, BTech completed. This is what the situation. If this is a situation, how do you get the jobs and all? Finally, electrical branch is waste. Majorly 90% of the people I have seen, say electrical branch, future is not there. Right? What I have to do? Electrical branch is having the best number of, huge number of opportunities compared to other branches. IN, you also come into electrical, don't mind. right? Electrical branch is having several opportunities compared to other branches, openly speaking. But still, 90% of the people are unhappy with electrical branch. Always unnecessarily have come into this unknowingly. Unfortunately, my bad luck. This always my bad luck will be continued. Bullshit. Nothing. Right? You are in the actual best branch. But we don't study. That's why problem is not with the electrical branch here. Problem is with the electrical student, openly speaking. Yeah, boy or girl, problem is with electrical student. Because so many resources are there. You are not utilizing that. Laboratory itself is to give the knowledge. What is that? 75% efficiency for DC machine you study in the classroom. Do you get 75%? No. Why? Means so many mistakes will be there. That's why. What is that? In the laboratory, machine you are using, machine has own drawbacks. Connecting wires will be drop and meters also drop. Automatically 65, etc. You'll come. You will blame the machine. I studied about 75% efficiency in the classroom. Machine is given 65. So machine is waste. My college is waste. My college management is not purchasing the good machine. Like that. So many statements will give. What you have to understand? We are the human being. Our errors are there. Plus instruments errors are there. And connecting wires drops will be there. Machine is a practical machine. Ideal efficiency will not get 75. In that way, if you are analyzing, okay, practically errors will be there. Practically, the value will be less than the theoretical value. In that way, you need to analyze. Why I'm giving all these means this topic itself is experimental topic. That's why I'm giving that. That's why I'm requesting everyone, those who are pursuing still for third year or fourth year, etc. All right, kindly next laboratories are there. No, kindly do them with full interest. Conduct the experiment with full interest, so that you can get the idea. Okay, faculty says that increase, decrease. You increase, decrease, BTech completed. And faculty says that press this button, press this button. You pressed it, BTech completed. That is what the main headache. That's what the main headache. Try to know, right? It's not your mistake. System is like that. That's why you don't fall in that. You go to the corresponding serious preparation, etc. Right. Yeah, I know. I have seen two kinds. This is what the main problem. If I say example, people are taking to hurt. See, I have given I have seen mixed kind of people. All I told you. Few people always sitting. Few people bias always roaming. But few people seriously giving bias or girls giving the correct. That is what the required thing. Lab means you need to do. Yeah, what is that your friend is doing? No, you need to do that. That's why combinedly you have to do the experiment. One students will be always wearing the rheostat. What will you get? Always where is the rheostat? Always observing the ammeter only. What will you get? Bullshit. Nothing you will get. That's why connection also you have to do compulsory, right? So this I wanted to say from starting day, but time has to come related to this experiment. That's what. Okay. You guys see very good here, very good. Right. So no, labs are not there. Labs are not there. You are a very unlucky person. Right. Okay, people are asking about me from so many days. See, I have worked in the college for 9 years of period. I worked in the college as an assistant professor, associate professor, and head of the department. I worked in 9 years. In that 9 years of time, last 2-3 years, I managed GATE class and college days, both. But it was hectic. After 9 years of service, I switched on to the full-time faculty of GATE, ESC and all. I have been working in ESC as a full-time faculty. This simple brief. Very good. If you give the connections, very nice, happy. Right, I have worked as a lecturer, yes. Very good, yeah. Tirupati Reddy, don't worry, yeah. See, when we are as the student stage also, we did also same thing, only for attendance. But after completion of BTech, we came to know that. Vasishta, thank you. Yeah, that's what actually due to this pandemic, everything is last year. Almost 2021 is over, 2021 is also over. People are doing the missions like online. What is this nonsense? But situation is like that. It is not your mistake. Kushi Erlagade, no problem. But situation is like that. Already when we used to go to the college, we don't get anything. Now, nothing. Corona batch, right? Okay. Yeah. Ashish Kumar, correct. In many colleges. See, one more thing I wanted to say. Don't think I'm wasting the time. Kindly concentrate. I did my polytechnic. In my polytechnic, 3 years of time, I have not used a single ammeter, but polytechnic completed. Right? Final year, one faculty came from other college and he asked that, what about lab? Means, oh, lab will be there. Lab means we go to the lab and we used to write observations, copying and recording completed. Final year, at the end of the final year, when faculty came and asked that, what about lab? What is ammeter? We don't know nothing. Last only 2-3 months, we have seen, okay, like this, laboratory will be there. That's what the present situation. We can't do anything. That is the reason why. Few things I will tell you by pinching. Few things I'll tell you smoothly so that you can understand. You need to understand. Very good. Bharati, after so many years, I got this statement from electrical student. Electrical branch is the evergreen branch. I always use this statement. Right. Very good. Very good. Right. Rahul Goruganti. I don't want to comment on that. Leave it. We have burned the generator in the lab. No problem. You get something knowledge. Okay, correct. Very good. Very good. Usha, very good. Very good. Without seeing the diagram, you can. Very nice. Yeah, that's what. See, Corona batch, no, we can't do anything. Whole world itself is like that. What we can do. Yes, okay. Okay, right. Now let us continue. Right. Thank you so much. Actually, I'll be taking sessions also, career opportunity sessions also I'll be taking, right? Throughout the morning, I'll be taking 2-3 sessions of career opportunities for all the branches. Evening, I'm taking this class in the ACE Academy. There I will say, electrical branch people are the luckiest people by showing all the opportunities available. That's why I'm saying the statement, you are the lucky people. But we don't know what are the things, that is not the main problem. Okay, now let us come back to the topic. Sir, VA and AV method. VA and AV method. Overrides? Right. See, instrumentation has two advantages. Saujanya, don't worry. Actually, if I say the word electrical, instrumentations are having electrical benefits, electronics benefits also. Don't worry. Instrumentation branch is also equally good. But for saying purpose, electrical word I'm saying, but instrumentation is also equally good because you can go to EC branch, you can go to electrical branch. Means you are the sub branch of both the combination. No need to worry. You are also equally good. If I forget your branch name, sometimes don't mind. Right. Vashishta, very good, very good. Right. Okay, now, sir, come back. Sir, now the next topic I'm taking, AC power measurement. AC power measurement. Right. See, on one day, people are asking that, sir, take one session also to us. People are saying that I will take the permission, I will take the session. No need to worry. Let us go back to the measurement topic now. This is about which one here? DC power measurement by voltmeter ammeter method and ammeter voltmeter method. Kindly don't have the second thought like, why not wattmeter? Did I say that? No, wattmeter is there, but also this method is also there. This method is also there. So don't worry. One thing. Second thing, sir, I'm taking the AC power measurement. After that, I'm going to solve plenty of questions. After that, I'm going to solve plenty of questions. Right now, sir, before going to that, I would like to conclude this point again so that topic will be continued. Sir, high resistance means current drawing will be less, low current. So low resistance means current drawing will be high, automatically high current load. That's why one more thing, electrical basic point, load must be represented with R or current or power only. Don't say low voltage load or high voltage load. No, voltage is constant. In our house, simple example, in our home, not house, in our home, 230 volts is there. Wherever the socket is there, you measure the 230 volts. Generally, I'm talking practically. But load, small load means small loads are there, large loads are there, means what is it? Small current loads, large current loads, small power loads, large power loads, or small resistive loads, large resistive we can say, but on the voltage base don't define, because in all over India, wherever you are, I'm at Hyderabad, you're at different places. No, in your home and in my home, voltage is 230 only, but current different. According to whatever I switched on, according to whatever you switched on, that depends on current and resistance and power depends on that. That's why based on the voltage we should not give. That's why I gave that here. Low resistance means okay, resistance is low, current will be high. Resistance will be low, current will be high. That's what this point. Clear? Okay. With this entire revision, I'm going to the next topic. That's what I told you. Sai Charan, just now I told you. Always. Right. Always, what is it here? Load must be represented with current or resistance or power, anything. No problem. That depends on manufacturing terminology. We can go for no problem. Next, I'm taking single phase AC power. Kindly concentrate. This topic is a separate topic, but it is just like a revision of earlier topic. Revision of earlier topic. What is that? So in the single phase AC power measurement, what I told you, EMMC device, which connection? MC short connection and LC short connection. Okay. Now what is MC short? What is LC short? After that also same question, which connection you preferred and what, everything same thing I'm going to say. What is it? You know, here MC short, LC short connection. Okay, MC short and LC short connection. Okay, sir, same concept here. It is just a revision, but earlier topic was a devices based topic. Present topic is coils based topic. That's it. What is that? Here, sir, load is there. Right. Here, small confusions will be increased, little bit more confusion. Be clear. AC means load may be resistive, load may be inductive, load may be capacitive, anything. But explanation purpose, I need to take one load. Explanation purpose, I need to take one load. I will take one load, I will proceed. That's what the point. One example. Okay. Right. Sir, this is the coil structure. Current coil, potential coil. Right? What is it here? In this already RL is there. This R is extra we have connected. I told you to limit the current. I told you. Okay. Right. Here also. Like this. Okay. Right. Sir. Here supply V phase. Here also V phase supply. Okay. Right. Sir, this is M main, L load, C common, V voltage, same thing. M, L, C, V. Okay, right, sir. MC short, first of all, current coil must be in series in the circuit. Over. Current coil must be in series in the circuit. Now, potential coil must be connected in parallel, but by shorting the MC, by shorting the M and C. Okay, and here by shorting the L and C. That's it. I have shown two connections, same connections I'm taking now. Now let us analyze which is better and which case error is less, etc. etc. We are taking now. Right, Saujanya, correct. I'll give you after this point. Commonly, I'll give you. Right? Okay. Now, sir, I'm taking one assumption. What is that? Assumption is, for example, resistive load I'm taking. Sir, why only? Example only. If I take inductive, why only inductive? If I take capacitive, why only? That's it. One load I have to take. Resistive load means power factor is equal to 1. Resistive load means power factor equal to 1. Right? Lakshmi Kiran, MLCV full form already I gave yesterday. Today also I repeated. I have revised at the time of starting of the class. Kindly go through that. Okay, now everyone concentrate here. Sir, it is just a revision of earlier topic. Be clear. Kindly concentrate more. Kindly concentrate more. Right here, sir. What is the true power formula? True power formula means voltage across the load is VL, current through the load is IL, voltage across the load is VL, current through the load is IL. Okay, sir. VL, IL. Right? What is the true power consumed by the load? VL, IL, and cos phi. So therefore, VL, IL into cos phi. But what is the load power factor? 1. So therefore, simply VL, IL. Suppose in the examination, power factor is 0.8 lagging, 0.6 lagging, substitute that value. That's it. Okay. Here, power true. VL, IL, cos phi. VL, IL. Okay. Right. Second one. Sir, how we are measuring the power? Power measured is equal to potential coil excitation flux into current coil excitation flux combination power we are getting. Already we have taken IC into IP, so and so. Yes, same thing. Here also, power measured is equal to potential coil excitation into current coil. Means here I told you voltmeter reading, because it is a meter, so I can say reading word. I cannot say potential coil reading. No, because potential coil alone, no, completely a device. That's why potential coil into current coil written. Okay, now let me take the continuation here. Right, the point here is this is MC short. MC short and LC short notation. Sir, here in this power measure, power measure. Okay, right. Now, the point here is, sir, power measure. What is that? Check it. Sir, in this potential coil, across the potential coil, how much voltage is there? Across the potential coil, how much voltage is there? Concentrate here. Across the potential coil means across the current coil and load combination. That's why before proceeding, now concentrate. Sir, everyone, potential coil is connected to the supply side. Current coil is connected to the load side. Go back and see here. Sir, voltmeter connected to the supply side. Ammeter connected to the load side. Both are similar or not? Not same, but connections are similar. Ammeter means current circuit load side, voltage circuit source side. Check it. Current circuit load, voltage circuit. So that's why this is similar to. Kindly don't get confused. Sir, how it is equal to V? No, no, no. It is not equal to. Similar to. So that you can understand these topics more clearly. Here also same thing. A first, V later. So this is similar to, means total revision will be done. That's why V and AV method notation taken. Okay. So potential coil excitation. Potential coil voltage equal to VL plus voltage across the current coil is VCC. There what we have taken? VA we have taken. Here we have to take VCC. That's it. That's why earlier topic only I'm revising again. But it is AC, no, coils based concept I'm giving. It is separate topic, but just like a revision. So therefore, what is that? VL plus VCC. Here what you have got? Here, VL plus VA. If it is there, you can replace this CC over. That's what the point. In the offline classroom, I do like this only. I will erase this and I will write CC. But here, I'm writing separately. Okay, now, here, power measured in this. Sir, voltage across the potential coil is directly voltage. Why? Voltmeter directly across the load. Potential coil is also directly across the load. So therefore, VL. VL. Okay. Now here, sir, current coil current is current coil current is current through the current coil is IL only. Yes, simply IL. Now here, so current through the current coil is equal to, at this point, it is divided into IL and IPC. IL and IPC. So therefore, yes, IL and IPC. Actually speaking, you can verify like this also. What is that? VL plus VCC IL there. VL into IL plus IPC there over. If you know this, simply voltmeter word replace with PC, ammeter word replace with CC over. That's what the actual discussion. Okay, right. Next one. Continue. Simple mathematics. Sir, here VL IL plus VCC IL. VL IL plus VL IPC. Same discussion. Sir, PM is equal to PT plus VCCIL. PM is equal to PT plus VLIPC. Same thing we have got, check it. PT plus VCCIL there, VLIPC. Same thing. That's why it is just revision. Kindly concentrate more. And what we can say now, error is equal to PM minus PT. What is PM minus PT? VCC into IL. Error is equal to PM minus PT. VCC, sorry, what is it? VLIPC. Okay, now same discussion. So what is VCC? VCC is the voltage across, what is it? Current coil. So therefore, current through the current coil IL, and coming again, current through the current coil IL into resistance of the current coil RCC. So therefore, I'm writing here, what is it? IL RCC. Therefore, I'm multiplying like this. So error is equal to this. If you observe this same error here, IL square RA, IL square RCC similar. Okay. Now again, error is equal to VL square by RPC, because IPC equal to VL by RPC. Check it. IPC equal to voltage across this, that is VL by RPC. VL by RPC. Clear? Now same discussion here. So percentage error, same formula. PM minus PT by PT into 100. Same notation. No need to repeat. So simply MC short, LC short, MC and LC short connection. So what is this? Constant continuation. Just I'm continuing. Sir, what is that? Error value. Percentage error is by VLIL. Same thing here. What is that? Percentage error is equal to IL square RCC by VLIL. Suppose in the question, power factor is given cos phi into 100. Percentage error VL square by RPC by VLIL cos phi. If it is given, take it. So this is the percentage error formula. Clear? Right? Now, concentrate. Sir, now very, very important point here. Sir, in this, error is due to. Error is due to. In this also, error is due to. Error is due to. Now tell me, sir, error is IL square RCC. RCC, current coil resistance. IL, current through the current coil means RCC, current coil resistance. IL also current through the current coil. Therefore, error is due to current coil. Error is due to current coil. Their ammeter, no, here current coil. That's it. Very simple. Error is due to. Simply I can write potential coil. Sir, why? Check it here. Sir, RPC. What is RPC? Potential coil resistance. VL. Check it here. Voltage across the potential coil is VL only. VL only. So therefore, what is it here? Voltage across a potential coil. What is the resistance of the potential coil? Combinedly error due to potential coil. Okay, here very important genuine doubt, general doubt is, sir, why you have taken just RCC? Why you have taken just RCC? Why not ZCC? No problem. You can take ZCC also because current coil has resistance and inductance. Potential coil also has resistance and inductance. ZPC also. You can take it. But according to the practicality I'm taking, whatever the textbook, whatever the numerical question you take, in all those numerical questions, in these models, they are not giving LCC and LPC in the question. So why to get simply RCC, RPC directly I'm taking. Other than that, there is no other logic at all. You can take ZCC, you can take ZPC, no problem. Even though you take ZCC and ZPC, in the question, LCC will not be given. LPC will not be given. So again, RCC only. That's why universally, which is suitable practically, I'm giving that. Yes, directly. Yes. Don't think too much on that. Very simple. Now, finally, same conclusion. Suitable for same logic here. Sir, this error must be low. RCC must be low. Already told you, current coil resistance is low. Okay, leave it. We cannot do anything. Already it is low. Happy. Sir, IL must be low. IL must be low means low load current. Less load current means resistance of the load must be high. So therefore, simply suitable for high R loads or low current loads. Same conclusion. Only their devices here coils. That's it. Here also suitable for. Sir, RPC should be high. In order to get this as low, RPC should be high. Listen, if you want to get RPC high, how means? Come on, manufacturer already provided the potential coil with high resistance. You no need to worry. You no need to worry. So therefore, it is already high only. Sir, in order to get less error, right? VL must be low. So VL must be low means voltage drop must be low. Voltage drop must be low means less resistance. So therefore, suitable for low R loads or high current loads. Same conclusion. But only the difference is their devices, that is DC measurement. Here coils, yes, but is that AC power measurement in this way. Clear? Okay. One point here is, sir, generally low resistive load means, see, load means generally our example is, what is that? Resistive load I have taken. Okay, happy. Suppose if it is inductive load, if it is a capacitive load, then what will be the conclusion? What will be the conclusion? Right? All I told you just now, the load cannot be represented with respect to voltage at all. Load cannot be represented with respect to voltage at all. Only either current or resistance or power only. Voltage based, don't give it. Okay. Now, the question here is, sir, if the inductive load and capacitive loads are there, simple logic, very good. High impedance loads, low current only. Low impedance loads, high current only. But, sir, generally, sir, high impedance loads are high R loads. High impedance loads. Everyone kindly keenly observe this 2 minutes of statement. Based on this, some other objective questions are there in the ESC paper. Numerical questions are there in both the papers. Concentrate. Suitable for high impedance. Suitable for high resistance. Sir, if it is high resistance load, high impedance load, it implies that low inductive or high inductive also. Normal logic. Impedance is high. In that, resistance must be higher side means it implies compared to resistance, inductive will be less only. Sir, why only inductive you are talking? Why not capacitive? Means almost 80 to 90% of the loads in the practical world is inductive loads only. Capacitive loads are very difficult to get it practically. Capacitive load means synchronous motor operate under some excitation, alternator operate under some excitation, that will be acting as capacitive load. So that's why most of the practical loads are inductive loads only. That's why almost all the theories I can say based on inductive concept only. That's why in your house also, suppose 10 loads are there, 9 to 10 loads, 10 out of 10 also nowadays inductive loads only. Rest loads are not there. Rest loads are olden days incandescent, yellowish color is there, no, incandescent bulb, that is resistive phenomena, tungsten resistive. But nowadays everything is inductive. Fan is inductive, AC is inductive, fridge is inductive, and mixer grinder is, everything is inductive load only. That's why in the practical world inductive load, therefore concepts also given based on inductive nature only. That's why I'm concluding this one. Concentrate here. I'm concluding. I have not completed the point. I will write. Kindly concentrate. Sir, high impedance loads, high resistive loads means low inductive load. Sir, inductive is low. Inductive is low means power factor is good or poor. Power factor is good or poor. Low inductive, power factor is good. Means immediately what we can say, MC short is used for good power factor loads. Simple logic. I'm coming again, I'm revising this point, sir. Low resistance for resistive load. Suppose it is an impedance load, low impedance. Low impedance, high current, satisfied. Sir, low impedance. In that impedance, resistance is low means compared to resistance, inductive terminology will be high because low resistance, as low as possible resistance. Inductive are not commenting. So therefore, as low as possible resistance means LE is looking higher compared to this R. Therefore, high L loads, high inductive loads, sir, more inductive, high inductive gives, good power factor, poor power factor. That's why be clear. Very, very important point here is, sir, MC short connection. What we say now, UPF loads directly UPF wattmeter we say. What I told you? High, what is that? Power factor, good power factor. Which is the good power factor ideally? 1. So therefore, conceptually for writing purpose, UPF, but it implies UPF, high power factor or good power factor. Almost same. But writing purpose, note purpose, UPF is it. It is very, very, very important objective bit. And LC short, which means poor power factor means high inductive means poor power factor means low power factor wattmeter. Complete concept I explain. I'm coming again also because it's very, very important. Concentrate, guys, everyone. Low current should be there. High resistance in the resistive loads. High impedance in the impedance loads. High impedance should be there. High resistance should be there means low inductive. Means if you compare these two, low inductive means good power factor, which is good power factor 1. So therefore, UP, actually speaking, UPF wattmeter only we say, but conceptually good power factor or best power factor or high power factor we should say. Now come to this. Sir, high current should be there means low resistance or low opposition or low impedance. Sir, low impedance should be there. Low resistance should be there means inductance value looking like high, highly inductive, poor power factor, low power factor. Same problem here also. I'm asking the same question. In your laboratory, MC short and LC short means, again people say that both connections. Be clear, in the measurement laboratory, MC and LC you will connect, you will compare. But taking same load, MC short, less error, LC short, more, like that you will prefer. You will compare, that is okay. But in the machines laboratory, which is short means undoubtedly MC short only, because I told you, in our laboratory, all the loads are resistive loads only, whether it is DC generator or it is AC generator or it is measurement lab. Generally, we purchase resistive loads only because those are the commonly available loads and cost is also less. Therefore, resistive loads MC short only, right? Only in one experiment, that is synchronous machine, ZPF lagging experiment will be there for electrical people. In that, only inductive load we purchase. Other than that, for any machine, laboratory, not real-time experience, laboratory to get the concept, therefore resistive load. That's why MC short only. Here also same problem. LC connects, what happens? If you connect LC, what happens? Same explanation now. Right? What is it here? Same expression. What is it here? In your laboratory, high resistance is there. Sir, if I go for LC short, check it. Sir, high resistance is there. Voltage drop will be more. Error will be more. Obviously, wrong method. That's why in our laboratory, as high resistive loads are there, generally we go for MC short only. Suppose in the measurement lab, same high resistance load only, MC short we cannot, LC short we cannot. We compare those two such that, okay, MC short, good, less error. LC short, poor, more. That's what the comparison in the measurements lab. But in missions lab, undoubtedly MC short only. And one thing, fine, one more log. It's not my topic, but idea purpose I'm giving. In the transformer or in the induction or anything, transformer, OC test and SC test will be there. In the OC test, LPF wattmeter you will use. Right? And means LC short. Yes, short circuit test, that is UPF wattmeter. That's what the point. Sir, why? You will understand the missions. Sir, why LPF in OC means OC test is nothing but open circuit condition is called as poor power factor condition technically, but that you will study in the missions topic. But idea purpose I'm giving. My topic application I'm giving. Yes, very good, very good. Yes, correct. Balakshna, correct. Right. We use MC short for LPF also, sir. Concentrate here, concentrate. Concentrate here. I'm talking about LPF wattmeter. LPF wattmeter generally LC short should be there. But after 1-2 discussion, what is the actual logic I'll tell you. But generally OC test, LPF wattmeter. LPF wattmeter is separately constructed and giving. But actually speaking, okay, I will erase this one. You are getting confused with this. UPF conditions and LPF conditions. Nothing but low power factor conditions. Generally in the normal wattmeter, LC short we connect. But LPF wattmeter separately constructed. In that construction, what they will do, I'll tell you. This is what the simple construction. Total discussion regarding this. Right. Very good question. Sir, here. Sir, how can you decide whether the load resistance is high or low? I don't decide. They will give in the question. They will give in the question. Yes, that will be, yes, high resistive load is there. So they will ask the question. Again, you are saying that same thing. How do you decide? That is the question here. I am giving high resistive load to you. I am giving high resistive load to you. Which method? That's what the point. I'm giving low current loads to you. Which method you prefer? That is what the thing. That's why if I say high or lower, I'm not deciding. That is a question already there. In the laboratory, low current application, safety low. That's why high resistant loads only. Clear? So this is what the complete. Again, same discussion. Sir, condition for same error in condition for same error in both MC and LC short connections. MC and LC short connections. What is it? Very simple. Same notation. Sir, in MC short, IL square RCC. RZC as you wish. VL square by RPC. Same thing. What is it? VL by IL root of RCC into RPC. VL by IL is RL or ZL based on the given data. Simply RCC into RPC. That's why I told you both are exactly similar. Both are exactly similar. Not same, but exactly similar. Right. Very good. Here, one small doubt is there. But you're missing small thing in my topic. Sir, irrespective of the thing, sir, Z is high means both R must be high, L must be high. But what is my topic here? L is not varied. I am not varying with L. I am talking about R is very high, R is very high, R is very high, R is very high. That is what my topic. Because the application may be resistive loads, application may be inductive loads also. That's why impedance must be high, Otherwise, R must be high. Inductance we are not commenting because our topic is resistive load is also there. No, combination of both. High resist means kindly consider. I am not saying that L inherently low. No, compared to R, L will be low. Why? Means we are going for high R, high R, high R, again high R. That is giving less error in MC short. And Z low means people are asking, sir, R low, L low. Actually, L is very low, very low, very low, very low, very low. But L, I'm not commenting, means I'm not changing. That's why this is LC short, low resistive or low impedance. Now, if you compare these two, experimentally prudent gave the here, if you compare these two, low inductive compared to high R. Otherwise, resistance is very high compared to L. So therefore, UPF condition. Resistance is low. Definitely, R is keep on getting reduced. Power factor is becoming poorer. LPF, that is what the concept. Kindly, whichever I'm taking as a variable, whichever I'm taking as the constant and not varied, that I have to understand. Right, very good, Vamshi, correct. Right. Again, Lakshmi Kiran asking the same thing, sir, which is high, which is low, why are you worrying? He will give in the question, take this high resistor load, what is it, etc. Otherwise, wait for 2-3 days. In the bridges, I will give you which is low resistance, which is medium resistance, which is high risk, like that I will give you. If you have the patience, wait up to that point. Clear? So this is the total discussion regarding MC and LC short connection. Right. See, don't say that. So it would be more clear if I keep HPF. No, you should not at HPF. You should at UPF only. As an electrical engineer, as an instrumentation engineer, you should have these basic concepts like UPF means perfect purely resistive load will not be there practically. Pure resistive load will not be possible. That is the reason why UPF wherever I'm taking UPF, it implies okay, higher side power factor. That is what the concept. As an engineering student, electrical and instrumentation, you should have this basic point. That's why I told you HPF, GPF, good power factor, but statement writing purpose, we should write that only. Soundarya, very good, very good. In that way, you can. Right. Sir, if Z is high by keeping R, that is not the concept. Kindly try to understand the concept. What is it here? You know, here by increasing Z, by keeping R, you're missing small thing. The corresponding statement should be common for resistive loads as well as inductive RL combination loads. That's why resistance only to be varied. On that based only, the concept is given. Take it for granted. Take it for granted. Right. LC connection, what is the value of cos phi? Low power factor. But what is it? We'll be seeing that. He will mention, no need to worry. Low power factor, which is to be taken as low power factor. Tomorrow only, I am going to take the entire discussion. Don't worry. Don't worry. And people ask, one student is asking that, Vinitha, can we access to watch those? No, yeah, no, not access. Actually, those are not recorded class actually. Those will be only online classes. It will be vanished, not recorded one. Don't worry, if you are that much interest, I will take one extra session. I will take the permission from them and I will take that. No need to worry. No need to worry. Right. Now with this entire topic, what is it? DC power measurement as well as single phase AC power measurement is done. Single phase AC power measurement is done. Now we are going to have the numerical questions on this. Right. OCA test why UPF kindly in the missions it will be more clear. If I want to explain almost 20-30 minutes of topic which is not related to my topic. Simply this I gave you just for continuation link. I need to make measurement in the missions link. I made after that kindly. Your answer is correct only. In that way we can think. Right. Right. Now let me take questions. Read this, take this question. Right. Try this. Take 2 minutes of time and try. Right. Yes, very good. Sir, in this you have to understand one thing. Here, current coil resistance. Okay, check it here. Inductance will not be given in these models. And pressure coil resistance 6000 ohm. Calculate the percentage error if the wattmeter is so connected that the current coil is on the load side. So which connection indirectly? Current coil is on the load side means which connection here? MC short connection. I'm going back and I'm showing here. Current coil is on the load side. Current coil on the load side means MC short connection. Okay, right. Now, what is the voltage? VL is equal to 220 volt. IL is equal to 20 ampere. Power factor is given is 0.6. What is the error formula? Percentage error equal to IL square RCC by VL IL cos phi into 100. Substitute all the values, we'll get the answer. Of course, many people give the correct answer. Very nice. Yugasri, check it. Hema, check it. Pallavi also kindly check it. Sunil, can you check it? Power factor is given. You need to substitute the power factor value compulsory. Ashish, correct? What's the answer? 0.45%. Right? Okay. Now, one more question. Same data, but reverse connection. Same data. What is it? 1 second. In the earlier question, current coil is on load side, right? Same data. Pressure coil is on load side. Other formula. Yes, point for correct. Very right. What is the formula? Right. So percentage error equal to VL square by RPC by VL IL cos phi into 100. VL 220 square by RPC 6000 by 220 into 20 into 0.600. We'll be getting 0.31%. 0.31%. Everyone has given that option B. Okay, right. I'm stopping now. Let us take the break and come back. Right. If they ask to find out the worst percentage error also, same thing. Why? Worst percentage error means maximum error, AM minus AT by AT only. Yes, PM minus PT by PT only. Same thing, same thing. Percentage limiting error only. You have to calculate. Worst case means maximum possible error is there. That is the worst case notation. Clear? Okay, let us take the break and come back. Right. Come back. Right. Let us take few more questions. One second. Same method. Right. Now in this question, he has not mentioned which is the resistance of current coil, which is the potential coil resistance. But by observing the resistance values, you need to understand that here the resistance of two coils of a wattmeter directly given. So therefore, small value of resistance is, what is it? RCC. Large value of resistance is 1000 ohm. Load current is 20 amperes. And VL is 30 volt. In this be clear, in one of the two way of connecting the voltage coil, means he is not mentioning which is in this he is not mentioning the connection is MC short or LC short. No, but he's saying in one of the two way of connecting the voltage coil, the error in the reading would be, means you need to concentrate on two methods because he has not mentioned which method is to be taken. So that's why percentage error equal to in MC short, what is the formula? IL square RCC by VLIL. Check it. Power factor is not given. So simply leave it 100. In the same way, percentage error is equal to VL square by RPC by VLIL into 100. That every value is there. Now substitute and tell me in both the cases what is the answer you are getting. Right? In this you are getting 0.66%. Okay. In this you are getting 0.15. I hope everyone got it. 0.60% and 0.15%. Yeah, 0.66 means 0.60. No problem. Correct. Got it? Yes, sir. Among these two, anyone may be there. That's why in one of the two way of connecting the voltage coil, in one of the two way of connecting the voltage coil means in two connections, anyone will be there. Yes, 0.15 correct. But people are saying that, sir, this is correct. This is wrong. People are saying, no, yeah, it is also correct. But among these two, one will be there in the option. That's what the point. That's why it is also correct, but don't comment anything. But sir, what is the meaning of comma high? What is the meaning of high? The point here is, sir, what is the meaning of high? You know, I told you already, in both the cases, PM is greater than PT. PM is greater than PT. Therefore, error is positive. Error is positive. That's why as the measured value is high, error is positive. In the exam representation, instead of giving the positive or simply comma high, they will say, what do you mean that? Okay, error is positive. High is a terminology. So automatically answer is option C. Right. Now, same question may be given like here. This will not be given. This entire statement will not be given. Error in the reading. Suppose if they have given like that. Suppose if they have, this option may be given as 0.66% comma high. What the answer now? Both are correct. That becomes MSQ model. Means only find out the error in the reading. Connection he has not given MC or LC. Therefore, you need to do both. Yes, multiple, what is it? Select questions model also they can give. Clear? Right? Let me take one more question. See, in this, concentrate, guys. Bhavani, concentrate. In this, he is not asking which method is preferred. No, he is asking error in the reading. He is asking error in the reading. Suppose instead of this, they may be giving 0.66% high also. It is correct. That's why one of the errors he is asking, he is not asking which is preferred low error, high. No, numerically, this is what the thing. Right? Right. It is not the UPF. It is not the UPF. Did you see anywhere UPF is given? Power factor is not given. We assume like that. That's it. And one student, Amrit Shetty Sai Chand. So how did you take this one? Kindly go to the yesterday's class and revise the class notes. What is the current coil resistance and what is the potential coil resistance and all. Right? You can do this. What he is asking here? Here, what is current coil resistance are, right? Which makes the connection error the same in the two cases, which makes the connection error same in the two cases. Means he is asking simply, what is that value? Same error should be in both the cases. What is the condition? REL is equal to root of RCC into RPC. What is REL? VL by REL. RCC he has given a small r into RPC as it is. So substitute all the values and find out R. Oh, that's it. Many people have given option C, but one student has given option B. Concentrate 0.01, 0.1, small mathematical confusion. 0.01 ohm is the answer. Yes, correct. Yes, everyone has given the correct answer. So these are the few questions in the corresponding power measurement with respect to the coils connection. But in this, some other topic is there. Kindly concentrate. Here, very important topic. Error due to self-inductance of potential coil. Error due to self-inductance of potential coil. This is what the next topic. In this only, AC power measurement only, error due to self-inductance of potential coil I'm taking. Okay, one second. IL. RL equal to VL by L. Dinesh, what is the problem here? How to find R value? Substitute the values here. VL value 200 is given in the question. IL value 20 is given in the question. Root of R. RPS is given as 10 kilo ohm given in both the figures. So 10 into 10 power 3. Do you need to solve further or can you solve it? Vishnu, kindly go to the yesterday's class and get that. No, people are asking why do we need two coils in EMMC? I told you already, EMMC name itself indicates two coils should be there. That's what the terminology. Moving iron single coil, a PMMC single coil based on the name EM one coil, MC one more coil, two coils. I told you already. Right. Sir, error due to self-inductance of potential coil. Kindly concentrate. Sir, in this, first I'm taking the topic. See, it is almost half an hour plus topic. Kindly concentrate each and every step by step. Finally, you will get some conclusion. Kindly concentrate on the mathematics as well as conceptual part also. Be clear, guys. Current coil, right? And potential coil, right? Here, load. This is a general circuit. V phase, right? And VL, IL, right? Now, sir, current coil, potential coil, and in the data, in the given data, if no connection is mentioned, always we prefer MC short assumption only. Only MC short assumption. Especially it is given like low power factor, etc. Else otherwise normally MC. So therefore I'm taking yes, here to here connected, here to here connected like this. All the theories are with MC short only. Okay, current is coming. What is this current? IC. This current IP or IPC as you wish. ICC, IPC, no problem. So same IC flowing through load IL. Yes, sir. So therefore, first point, what is that? IL is equal to IC. Another, all the theories are built up based on the MC short. I told you, yes, MC short connection giving IL equal IC. Sir, across the current coil, large voltage drop or very small voltage drop will be there. Across the current coil means immediately ammeter function, voltage drop must be as small as possible because less resistance, less opposition is there. That's why, sir, suppose supply voltage is 230. 230 is coming over here. 230 is there. Now, across this current coil, how much voltage will be the drop voltage? Across this current coil, how much will be the voltage drop? Very negligible. We neglected. That's why one more thing is VL is equal to V phase. These two are not assumptions. These two are taken for granted. I'm coming again. Sir, V phase across the current coil, 1 volt will be drop. So for example, 230 minus 1, 229. So 229, 230 both are same. One can be neglected. In that way, current coil drop can be neglected. This is the simple theory, simple introduction to start my entire topic. Clear? Right, sir. Error due to self-inductance means that's why I'm writing terminology. Sir, I'm separating the inductance and resistance completely. Sir, in this, which is there here? RP is there, LP is there. This is extra resistance R. Here, what is there? RCC will be there as well as LCC. But our topic is only potential coil. So no need to worry about this one. Clear? This is a coil in which RP, potential coil resistance, is there, inductance is also there, and this R is, as I told you, to limit the current. This R will be added in the day before, in the yesterday's class. I told you like this. Some R I have shown. Potential coil is already having RL combination, but to increase high resistance, I told you, 1200 ohm voltmeter, 2400 ohm voltmeter is like that. If you keep on increasing that, yes, R will be increased, R will be added here symbolically. Okay, right now, sir, in order to find out the error, what we require? In order to find out the error, what we require? Error is equal to PM we require, PT also we require. But unfortunately, in this topic, we don't know PT, we don't know PM, but we should get the error. That's why our duty is to get the true value of power formula, measured value of power formula by the concept and mathematics and phasor diagram and all. Finally, we need to talk about error calculation. That's what the point. Okay, right. Sir, now I'm taking true value. Sir, in order to get the true value, which condition I should take? Ideal condition or practical condition? In order to get true value, we should take ideal condition. Okay, I'm taking ideal condition. Okay, now concentrate, guys. Until I complete this, kindly keep on observing the statements and mathematical equations what I'm giving, because step by step, if you take, finally you will get the complete conclusion. Otherwise, it's very easy for me. Yes, these are the derivations not required. Follow 1, 2, 3, 4, 5 points. Error will be there. Over. But how we are getting all these are also I'm giving, because each and every step is written on some concept topic. Concentrate here, sir. Ideal. What is that? I'm taking the circuit. Current coil, right? Potential coil, right? What I'm doing, kindly concentrate. After that, don't get confused like how I have taken like this and all. Here, in this, what is it here? RP and R is there, no? Otherwise, I'm writing like this. Simply this are also, this as also just R letter, just R. This R letter I'm taking like this. So R and R combination I'm showing separately. That is what here concentrate. In this potential coil inductance, I'm separating L, right? Resistance is there, no? I'm showing separately. And one more resistance is there, no? I'm showing like this. This is R. Okay, this is R, this R, this R. Okay, and otherwise to avoid the confusion, I'm writing PC like that. You can understand. Now I'm writing this as RPC. This is internally available, but for clarity purpose, I'm showing separately. Nothing but here, this is the potential coil, means R is there, L is there. And this is extra resistance manufacturer only added to show that, yes, it is drawing very small current, error will be less, etc. This R I'm showing separately like this. This are I'm showing separately like this. Clear? Okay. Now, after that, it is connected over here. Sir, this is V phase. This is VL. This is IL. If still confusion is there, you can remove this. You can remove this. Here only you can write R. No problem. But I would like to show, what is it here? Error due to self-inductance of potential coil. No. So I want to show inductive portion separately. Practically, you cannot separate. Mathematically, circuit wise, we can separate. So that I'm showing that L separately. That L separately. Right? But generally, people ask this doubt again. To avoid the confusion, I'm taking like this only. In this R is there already, right? Only ideally, be clear guys, sir, ideally, right? Error due to self-inductance of potential coil means ideal means no error. Ideal means no error. Sir, ideal means no error. No error means inductance should not be there. That's why LP is equal to 0 I'm taking. So how can you take LP 0? I'm not taking practically. I'm taking ideally. Why? Ideally, error should not be there. Which error? Inductive error. So inductance itself, I'm removing. So automatically, whatever the value we are getting, we are going to get that value as true value. Kindly concentrate. This type of topic I explained in the starting days only. True value, ideal, true value, practical one, practical to loading effect concept, you know, same thing. Ideal means corresponding error should not be. Which error? Self-inductance. So I'm making 0. But will it be 0 practically? No. That's why ideally I'm making 0. Okay, right. Sir, this is IP. This is IC. Okay, coming over here. Now, one phasor diagram here. In my entire subject, first phasor diagram drawing. What is it? You know, concentrate. Sir, this is VL is equal to V phase. Already told you, V and V phase both are same. I am taking as a reference. This drop is neglected, no need to worry. Sir, current coil, current IC or load current IL both are same. That is flowing to the load. Sir, what is the load nature? We don't know. That's why I am taking the heading as which load? Inductive load. Right? If I take resistor load every time, people are getting confused. Why only resistor? That's why I have taken resistor load in earlier topic. Now I'm taking inductive load. In future, I'm going to take capacitor. All the loads will be covered. No need to worry. Okay, inductive load. Sir, if the load is inductive, IL lags the VL or leads the VL. IL lags the VL. So therefore, IL. Sir, IL is equal to IC. Lags the VL. How much angle? We don't know. That depends on the load. 5 I'm taking. Just 5. We don't know. 30, 40, 55, anything. Sir, IP, concentrate. IP is this one. IP is flowing through potential coil. But in the potential coil, under ideal case, we assumed LP is equal to 0. Means the potential coil is completely resistive coil. So therefore, current through the resistance, voltage across the resistance. Current through the resistance and voltage across the resistance. Both will be in phase. So therefore, I, which one? P. I'm coming again. Sir, current. Which one? Through the load, lagging load, inductive load means lagging load. How much? 30, 40, we don't know. Yes, IL lags the V phase. IP is the current through which coil? Resistive. Sir, why? Ideal case means LP I made 0 because practically we cannot. Ideally we can eliminate. Why? We want to get a true value of power. Okay, IP in phase with V phase. Yes. Now in this EMC structure, no. So what is that? Torque TD is equal to. What is the formula? Yesterday's class. IC IP cos of angle between these two into dm by d theta. Same thing I'm taking because it is power measurement only. Right. Bhanu Chandra Nayak, VL is not equal to V phase, no sir. Already I gave you VL equal to V phase. Why also I gave you? Go back, watch the recorded video. Okay. Right, sir. IC IP. Right. Like what? IC current coil potential cos of something dm by d theta. Okay. Sir. Now I'll proceed here. IC I'm keeping as it is IC. IP also as it is IP. Sir, under this case, angle between I, IC and IP, check it. IC, IP, angle is how much? 5. So therefore, now we can write cos 5. Here you don't write this, is a universal formula. We don't know. But from this data, yes, we know. Write this. dm by d theta. Okay. Still, IC. Sir, what is IP? Sir, what is IP? What is IP? Check it here. IP is the current through potential coil. So what is the current through potential coil formula? Voltage across the potential coil, resistance of the potential coil. So therefore, V phase is the voltage. Resistance, sir, this is there, this is also there, no? So combinedly, I'm keeping as total RP. I'm keeping as total RP. That's why here, just take R notation only. Clear? Into cos phi into dm by d theta. Sir, for a given circuit, dm by d theta is constant. How already told you yesterday. Sir, RP is also constant. How also? What is it? For a given device. For a given device. For a given device, what is it here? RP constant. We cannot change it. RP. Therefore, TD proportional to IC. What is it? V phase into cos phi. Sir, what is the VI cos phi? VI cos phi is power. The two without any change in the formula as it is formula. That's why what we can say, this is which one here? True power related. Actually, without this also, if you want to skip entire thing, what is it? Okay, true power, V into I into cos phi over. But how do you get true power? Means by taking the ideal condition. What is ideal condition? LP is 0. LP is 0. Again, people are asking, sir, VL equal to V phase means RCC is 0. What are you doing while I'm explaining? What are you doing while I'm explaining? Vishnu, did you sleep while I was explaining? Bhanu Chandra, what did you do while I was explaining? Are you sleeping? Right? I told you clearly, current coil opposition, current coil resistance, current coil impedance is low. I gave the example also. This is 230. This is 1 volt approximately. This is 230. This will be 229. We can neglect the one. That's why VL equal to V phase we can take, I told you clearly, by neglecting this voltage drop. Kindly don't sleep while the class is going on. I'm requesting everyone. Right? Okay. Now, sir, this is a true value. Okay. But now, very, very important task. At least wake up for this topic. All people. Sir, second case I'm taking. What is second case? That is practical. That is practical. Sir, practical means error cannot be 0. That's what the point. Yes. So in the practical case, sir, current coil, load, right? And here supply voltage V phase as it is. Here potential coil, inductance and resistance like this. This is extra R. Here R is there and LP is not equal to 0. Why? Practically you cannot make it 0. Why? That will be there. Coil itself indicates inductive nature will be there. That is what practical. So far I have taken ideal case so that error is not there. Error is not there means true value. Now I'm taking the practical. Practical means yes, error will be there. How? I'll tell you. Now, sir, this current is IP. This current is IC as usual. Sir, load VL, current IL, same thing. But in this little bit increased phasor diagram will be there. What is that? Before that, concentrate. Sir, now the potential coil is resistive coil or impedance coil. Impedance coil. Why? L is not 0. R is anyway there. RL combination. Impedance coil. Therefore, potential coil. We can draw impedance triangle. What is that? Sir, R and R. I told you. R and R completely RP. I told you. Yes. Therefore, concentrate, guys. Sir, this is RP. This is RP. Sir, LP is also there. This is LP. Okay. Sir, this angle I'm taking as some beta. What is this beta? Impedance angle of the potential coil. Immediately I'm writing this. Immediately people are asking, sir, why you have not taken this in the earlier topic? Be clear. In the earlier topic, if I want to draw, this is RP. LP is not there. LP is not there. So therefore, no need to. That's why in this LP is not there. So therefore, what is it? Beta is 0 only. So that's why in the earlier topic, what is it? It is pure resistive. No need to take. But here, impedance triangle RP, everyone knows horizontal, XLP, XLP vertical. B angle is beta. So from this, what is cos beta? What is sine beta? What is tan beta? Let us write and let us keep it with us. What is cos beta? What is cos beta? This is combination ZP. Okay. What is cos beta? Adjacent by this. RP by ZP. Sin beta, opposite by hypotenuse. XLP by ZP. Tan beta, opposite by adjacent. XLP by RP. Clear? Okay. Now, after that, sir, here I am taking the phasor diagram. Kindly concentrate. Kindly concentrate here. This is VL is equal to V phase. VL equal to V phase. Okay, sir. Current coil current IC is equal to IL. Still our topic is inductive load only. Inductive load only. Ideal case true value. Practical case measured inductive. So therefore, IL that is equal to IC. Angle will be phi. Common. Sir, now potential coil is, come on guys, potential coil is impedance coil or resistive means R and L combination is there. R and L combination. That too I told you, potential coil resistance is very high. I told you. So compared to that high resistance, inductive portion will be less, and I'll prove that also. That's why less inductive we can say. Why, sir? I'll tell you. I'll prove it. Therefore, resistance is very, I told you already, potential coil resistance must be as high as possible. That's why we are adding one more resistance here. I told you in the yesterday's class. That's why what we can say now, the current coil current IP, because RL coil no, lags the V phase, but inductive portion is lesser. So therefore, like this. What is this? IP. This angle is which one here? Potential coil angle is beta. Potential coil angle is beta. Right? Now tell me, sir, what is the angle between IC and IP? What is it here? Phi minus beta. When lagging load is being taken. Okay? But people are asking, again, this doubt will be continued. That's I'm clarifying. Sir, why not IP comes here? Why not beta will be here? That's why be clear. Beta value for practically designed structure very small. Sir, why? Also, we are going to prove that only by taking the practical designing. I am going to prove that only. Okay, right now let us take the same TD formula. TD is equal to IC IP cos of something into dm by d theta. Sir, what is IC? As it is, IP as it is, cos of, sir, angle between IC and IP under practical condition with the including of which one? LP. So what is it here? Cos phi minus beta into dm by d theta. Cos phi minus beta into dm by d theta. Okay. Now, sir, same procedure. IC. What is IP now? Check it, guys. Check it. IP is current through this RL combination. Voltage is this. So therefore, I is equal to V by ZP because R is there, L is there. So therefore, V phase by ZP. V phase by ZP into cos of phi minus beta into dm by d theta. IC V phase by ZP cos phi minus beta into dm by d theta. Clear? Okay. Now, continuation. I'm writing this equation here. TD equal to IC V phase by ZP cos phi minus beta into dm by d theta. dm by d theta. Okay, right, sir. I'm proceeding now. IC as it is, I'm writing. V phase also as it is. Sir, ZP in terms of RP. ZP equal to RP by cos beta. Can we write? ZP is equal to RP by cos beta. Yes. RP by cos beta. I'm writing over here. Into cos phi minus beta into dm by d theta. This is the torque TD. Now, sir, dm by d theta is constant. RP is also constant. So therefore, TD proportional to IC V phase cos beta cos phi minus beta. Okay, sir, what is the power formula? V into I into cos phi. But here V into I, same, but cos is disturbed. Disturbance is there means practical. So automatically, yes, this is related to which value? Measured value. Practically, we are obtaining. So this is the true value. This is the measured value. Otherwise, see, if I don't want to give this entire topic, it is not required. Mathematics only. This is the measured power. This is the true power. What is it? Remember it? No, I'm not giving that. I'm giving the complete explanation step by step. In all these things, electrical basics, electrical engineering basics are available. That's why step by step I have taken for revision purpose and conceptual also. Numerical questions. All these are very, very important. Right. MC short is always preferred. All the theories are made up of or made by the reference of MC short only, unless and until it is mentioned as LC short. Right? If it is mentioned as LC, then only you take it. Otherwise, all the theories universally based on MC short only. Ideal or practical anything, all the concepts are based on MC short only. That is the reason why MC short normally, MC short ideally, practically also MC short means all the concepts are built up based on what is that? MC short only. MC short only. Right? Our heading is kindly Kushal Nanode. What is our heading? Kushal Nanode. What is our heading? Potential coil data or current coil data? So I'm talking about potential coil data. So current coil, no need to worry. No need to worry. Right? Now, come on here. Before going to this, see, I'm writing now. So therefore, sir, so far I have taken only basic idea what we require. Now I'm taking, sir, power true formula, what we got in our derivation, power measured formula, what we have got in our derivation. Concentrate. So power true. What is the power true? IC V phase cos phi. Power only, right? So simply IC V phase cos phi. Power measured IC V phase cos beta cos phi minus beta, cos beta and cos phi minus beta. This we have got it in this. Before proceeding this entire error analysis, now I'm repeating because instrumentation people generally may be facing the problem with angle. Concentrate here. Sir, load current, concentrate guys. Load current IL, right? IL lags the voltage. IL lags the voltage by 5. That is 36.86 or 40, 45, like that will be there practically. Sir, IP is current through RL combination means lagging only. So therefore, IP is the current through RL combination. So IP lags the corresponding voltage. But here doubt will be there. Sir, this lagging is more or this lagging is more means simple logic. One more way I'm giving. This is after all a circuit. This is after all a device. But this is our house. Total house load, total industry, total college, like that means which is high capacity. Obviously, load is high. This after all is circuit only. That's why this lagging is less compared to this one. So therefore, yes, IP lags the V phase. IP lags the V phase by correspondingly supply voltage V phase. That is beta. That's why this potential coil angle is always less than the load, because load may be house load or two house load or an apartment, etc., etc. But after all, a circuit therefore will be less only. That's why beta is less than 5. And I'm going to prove also why should be beta low. I'll prove it. But conceptually, I told you, mathematically, I'll prove it again. Mathematically, I prove it again. Clear? Right. Dinesh, how to draw impedance triangle? Yes, network theory based only. Right. Kindly, network theory is not done in the AS Academy. Don't say for everything. BTech, first year, second year, third year, something you have completed. So therefore, impedance triangle is there in the circuits. Kindly recollect it. That is what? Yes. Right. Clear? Right. Now come back. Now let us go to the corresponding mathematics. Whoever asked me to explain that, I explained. Right. Sir. Now I'm taking the error analysis with this. Sir, error is equal to PM minus PT. Error is equal to PM minus PT. Is that no? Or PM minus PT by PT into a percentage error. That is okay. Now, first of all, PM is greater than PT or less than PT. See, I see V phase cancelled. Okay, now tell me, this is more or this is more? You are the mathematicians. Kindly give the correct answer. Which is more? Come on. Okay, okay, okay. Be clear, you're missing small point. Many people give the wrong answer because generally, yes, generally for this question, mostly people give the wrong answer only. Many people give the wrong answer that PT is greater than PM. No, PM is greater than PT. Sir, why also improving? Suppose phi depends on the load. Let me take 45 degrees something as you wish, 30, 40, 50, anything. But what I told you just now, beta, very, very, very low value. That too, what is it here? I gave clearly, this is a big industry, big house, but this after all is circuit, very, 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 very smaller value. That's why I'm taking here this as 1 or 2 or 3. Everyone take it for granted. In the designing stage also, whatever the manufacturer designs the potential coil, that is with very, very, very low beta only. Take it for granted. I'm going to prove also why it should be designed like that. Now, sir, true value, our true value, cos phi is there. Cos 45.707. Measured value, what is there? Cos beta, cos phi minus beta. Cos beta, which one? 1 I'm taking, for example. You can take 1, 2, 3, but not 10, 20, 30, 40 will not be there, should not be there. I'll prove it mathematically. But practically, I'm giving this. Cos 45 minus 1, 44. If anyone is having the habit of using the calculator, kindly simplify this. You tell me how much you're getting. You'll be getting 0.7 something, you'll be getting 0.71 something, you'll be getting. Yes, very good, very good. Okay, right. Those who are given PM is more correct. Go check it here. Sir, 0.707, 0.71. Which is more? Which is more here? Yes, PM is more here. 0.79 something will be there. This is 0.70. Of course, close only. But in that close also, what is the difference? 0.707, 0.719. Automatically, yes, this is what the point. Clear? Now, automatically, what is it here? PM greater than PT. No second thought. I gave the proof also, but kindly don't get confused like why we have to take like this only. Load, you take 30, 40, 50, 60, anything that depends on the load. But beta must be as small as possible. All I told you, why also told you, this is after all a circuit device. Compared to this, very less will be there, should be there, and mathematical also will be proving. After experimental analysis, they have taken this. I'm taking the mathematical proof also. Clear? Let us proceed now. So PM is greater than PT. Okay. Then error is positive. PM is greater than PT. Error is positive. Okay. So I want to find out the correction factor. Did you remember in the starting days, in the error analysis, I have calculated the in the starting days, in the error analysis, I have calculated the correction factor. Remember? PM into correction factor is equal to PT. I don't know how many of you remember. Very nice. Sir, correction factor is equal to, very nice, AT by AM. Our topic is PT by PM. Sir, PM is greater than PT. So therefore, correction factor is less than 1. Be clear, guys? In the ESC objective or in the GATE 1 mark model, question is, under lagging load conditions, error due to self-inductance of potential coil is dash, positive or negative, positive. Correction factor is dash, less than or more than 1, less than 1. Okay. After that, if he is asking like find out the correction factor, what is PT? This one. PM, this one. What will be there? Cos phi, cos beta, cos phi minus beta. If he is asking the numerical question like find out the correction factor, get it. Okay. After that, actual topic is error, right? So percentage error is equal to PM minus PT by PT into 100. PM minus PT by PT into 100. Sir, don't substitute these and don't proceed right now. I'm giving some other logic. Sir, divide here. PM by PT minus 1. PM by PT minus 1 into 100. Therefore, percentage error formula, other way of representation is, sir, correction factor is PT by PM. PM by PT will be 1 by correction factor minus 1 into 100. In your examination, 1 mark model question may be given like this. Sir, correction factor is 0.9. Correction factor is less than 1, no? 0.95, 0.98, 0.99, like that. Simply, correction factor will be given. You will be asked to find out which one you have. Percentage error. Follow this formula. After that, sir, percentage error is equal to 1 by correction factor minus 1 into 100. I gave you know. Yes, sir. What is correction factor? What is correction factor? This one. 1 by means reverse. So therefore, I'm taking that here. Cos beta, cos phi minus beta by cos phi minus 1 into 100. This is percentage error. Now your mathematical explanation. Simply take the cross multiplication, simplify. Kindly, this is mathematics. No need to worry. Up to the total technical based mathematics I have taken so far. But here, cos A minus B, like that only. So simply proceed. And you will be getting percentage error is equal to tan phi tan beta into 100. But already told you error is positive. No, yes, I'm keeping positive symbol. So this is what the error formula. This is error due to self-inductance of the potential coil. Error due to self-inductance of potential coil by the complete mathematical derivation I have taken, because each and every derivation step is also giving some concept to you. So this is what the total procedure. Okay, sir. Error due to self-inductance of potential coil for which load? Which load? Inductive load we have taken. Now, without taking anything, simply What can be the error due to self-inductance of potential coil for a leading load? How can you answer? By the logic, by the technical logic. Tell me, how can you write it? Lagging load I have taken. Leading load, how will be the formula? Leading load, how will be the formula? Very nice, very nice, very nice. Very simple. Sir, error is positive in lagging load. Leading load, negative. Why? Simply phi positive lagging load, for example. Leading load, phi will be negative. Tan of negative, negative. So that's why I can write directly. See, I'm not skipping here. I'm not skipping. By the logic only, by the technical logic only, I'm writing. Similarly, for leading loads, what is that? Percentage error is equal to minus tan phi tan beta into 100. Yes, many people give that. Yeah, simply put negative. Very good, very good. Right. Gagan, who told it is a static error? It depends on the load only, right? For a given load, it will be changing. Right. Clear? Right. Now, universally, conclusion I'm taking. Universal conclusion. What is that? You know, percentage error due to self. The heading is same. Plus or minus tan phi tan beta into 100. Tan phi tan beta into 100. This is what the corresponding error formula. Now I'm giving more clarity here. Sir, plus symbol is for lagging loads. Negative symbol is for leading loads. Clear? Right. Now I'm analyzing the total concept. Mathematical including concepts I told you. Now with the error also I'm taking very important. Kindly concentrate. Purely basic notes I'm giving here. Concentrate. Sir, beta is large. Tan large value large. Error will be large. That is the reason why beta must be low or beta must be high. Beta must be low. But beta is not in our hand. Beta is what? Potential coil impedance angle. In whose hand? Manufacturer. That is the reason why. Be clear. While designing, the manufacturer should design the potential coil with less beta. How? What is the meaning of less beta? Less impedance angle means less inductance. Am I clear? So I'm writing here. Sir, during designing, what is that? Here, beta value must be low, right? To get less error. To get less error. Therefore, potential coil must be designed. Potential coil must be designed with low beta. That is low beta. That is, what is it here? Low beta. Concentrate here. This is R. This is beta, for example. This is XLP. Low beta means R. This is low beta. Low beta means what is it? Angle must be reduced means XL must be low. So therefore, what is it here? Simply low beta. Low beta means what is the point here? That is designed with which one here? Low inductance. Low inductance. With this, what we can say simply, sir, potential coil, I told you already, resistance must be high. And we proved that inductance must be low, L. This is what the complete conclusion of the coil construction model. Okay. And one student told that, sir, how it is static? I did not say static error. First point. Now I'm saying that, sir, during the designing, beta is in their hand. Therefore, beta they kept low. Therefore, percentage error is low. Okay, happy. But coming to the operation side, means during our operation, sir, phi must be low or phi must be high. Phi must be low, then error must be low. Therefore, when do we have phi low? Means the power factor of the load is good. If the power factor of the load is good, automatically cos phi is good, means phi will be low, means tan phi is low, means error will. That's why always in your power system generally you try for improving the power factor. Why? Error should be low. Improving the power factor means error should be low. Here also I'm saying that if the power factor angle, I'm writing here, second point. What is it? Here, the power factor angle, I'm writing if, because load can be changed. No, if the power factor angle of the load only, okay, power factor angle is low, right? Then tan phi is low, right? Therefore, what is it? It implies, what is it here? The error will be, the error will be less. The error will be less. What does it mean? Power factor angle must low means cos phi must be. Therefore, what you can say? Therefore, cos phi must be low means power factor must be high. That's why practically which type of loads you need to consider in the operation. Good power factor loads, so automatically percentage is less. Means if you are using 0.8 power factor load, 0.9 power factor load, 0.95, 0.96, if you keep on increasing your power factor, error will be low. That's why error depends on load, error depends on construction also. Construction by the manufacturer, load choosing by the operator. Two things I'm giving. One is a designing stage, one is operating stage. That's why finally what we say here is, in order to get the less error, manufacturer should design the potential coil with low inductance, and operator should use the good power factor, high power factor loads. That's what the point. Plus or minus, that is different nature, but magnitude is this one. Clear? Right. In this, for getting more and more clarity, yes, we'll be solving the questions on this, but varieties of questions I'm giving here. First question, concentrate. Sir, cos phi is 0.8, right? Beta is 2 degrees. Concentrate. Just in what way I'm giving to give the concept I'm explaining now, right? Cos phi is 0.8, beta is 2. Second question immediately, cos phi is 0.9, I'm increasing, but beta is, what is it? 2 degrees only. Let us find the error. Now tell me, without doing any calculation, which case the error will be less here? Second case. Why? Power factor is good. We need to prove that. Now, everyone, find out percentage error equal to lagging or leading, no problem. Simply neglect the sign, the concept. Tan phi, tan beta into 100. Kindly give me this value. Here also, percentage error tan phi, tan beta into 100. Sai Sandeep, is it percentage form or which one? Yes, yes. What is it? Here, 2.6. See, I have not the, I don't have the values. Randomly, I gave one question, 2.61. Second case, Sharat Kumar, you have given 2.35. For which one? Right. Okay. Here 1.69%. Now you can understand which is less. Power factor is good because designing constant, we are not changing. Power factor good, yes, percentage will be increased. Okay, now I'm taking the designing stage. Now I'm taking the designing stage, means manufacturer side. For a particular load, what is that? Beta is equal to 2 degrees. Cos phi is equal to 0.707. Some load I'm taking, right? Manufacturer side only. He is changing beta to 1 degree, but for same load he is testing cos phi is equal to 0.707. Tell me, percentage error is equal to tan phi tan beta into 100. 3.49, 1.74. Is it? See, I'm giving the values randomly. Kindly give me the correct answer. 3.4 and 1.74. 3.49, 1.74. You can understand. So beta large means the high inductance is there. More error. Beta 1 degree, less inductance is less error. This is what the numerical proof for my entire conceptual point. Dinesh, I'm asking in percentage form. 100 is there. Kindly see the screen. 100 is there. Right? So in this way, the questions will be asked. Okay, right. One more model. Consider here. Power factor of the load is 0.866 lagging. Right? The ratio of resistance to reactance of potential coil is 0.01. Find the error. Find the error. One student gave that 0.01. Other two students gave that Gurudatta Behra and Vaspalli Hema 0.577%. Correct. Right. Okay, I'll solve this. Percentage error equal to lagging load now plus tan phi tan beta into 100 plus tan phi means what is the value? Cos phi is 0.866. Phi is equal to 30, cos 30 only. So simply tan 30 into. So what is tan beta? Go back to the entire derivation once. What is it? Tan beta, check it here. Tan beta is equal to XLP by RP. 1 second, guys. 1 second, 1 second. Sorry, here. Sorry, guys, sorry. Reactance to resistance of potential coil. Okay. What is that now here? What is it? XLP by RP. So therefore automatically what is that? Tan beta means XLP by RP into 100. So tan 30 1 by root 3 into XLP by RP. How much value? 0.01 into 100. 100 points we cancel. 1 by root 3 means 0.577%. Few people have given already 0.577. Yes, you have taken the correct ratio. Right? In this way, the questions will be available in this topic. 1 mark or 2 marks model. Right, let me take one more question. Vashishta, kindly check it here. Tan beta reactance to resistance ratio of potential coil is XLP by RP 0.01 into 100. 1 by root 3. This is common. 0.8. 1 by root 3 is 0.577. Correct only. It is XLP by RP only. Yes, Jitendra, yes. Make it fast. Yes, very good. Sir, here. What is that? Given data, power factor is 0.7. Frequency is 50 cycles per second, means 50 hertz. To confuse you, terminology has changed. Wattmeter potential coil resistance RPC is 1000 ohm. LPC is 0.5 Henry. Check it, very small. And from this, what we can write? XLPC we can write. XLPC is 2 pi f LPC. Find out this value in ohm. Finally, percentage error equal to load he has not mentioned. No, lagging, no problem. Leave it. Tan phi, tan beta into 100. Tan phi. From this, cos inverse of 0.7. Calculate and get this value. You will be getting 16%. Yeah, many people have given the correct answer. Yes, correct. This is a total discussion regarding DC power measurement as well as single phase AC power measurement and corresponding one form of error. Right? Now, the next topic is, that's why I told you power measurement is very lengthy, still not completed. The next topic is three-phase AC power measurement. Right? Instrumentation people, instrumentation branch people, kindly, you need to have more keen observation. But electrical people, their life itself is three-phase. They don't know all these basics already. But for you people, this topic is completely new. This topic is completely new here, completely new. Right? So that's it, be clear. And the people are asking, sir, what about the losses due to coils? See the heading kindly. See the heading. What is my heading? Error due to only self-inductance. That's why every error will be there. Whatever he is asking, find out that separately. That's why don't forget the heading. Right? Right. Three-phase power measurement. Especially, of course, electrical people should concentrate, but electrical people's life itself is three-phase only, mostly three-phase. Every subject, network theory, power system, machines, etc. Three-phase. But instrumentation people, only in this you will study. But recently they have added machines. I told you I will take later. Right? Two machines are there for you and instrumentation people. Transformer and induction motor is there. In that induction motor, three phase is there. I will take that later to you. Instrumentation people separately. But for everyone, common topic is three phase AC power measurement. Very keen observation is required. For a few people, new topic. For a few people, lifetime topic. Because you studied already, but every time you need to use this one in our electrical engineering. So kindly concentrate a little bit more. Yes, definitely. So far we have taken, what is the topic we have taken now? Up to now, DC, AC, that is approximately, you also study in network theory, DC circuit, single phase, etc. But instrumentation people, three phase, completely new to you. Completely new to you. Yes, yes, correct. Now, correct. I'm taking, first of all, what is three phase? What is three phase? Means in this system, three phases are there. Three phases are there. So what is the meaning? First of all, suppose if I take DC supply, positive terminal will be there, negative terminal will be there. Positive, everyone knows that. What is that? Forward path. Negative means return path, we say. Forward and return path, we say. Right? Okay. Now the question here is, be clear guys, be clear. The point here is, sir, if single phase AC is there, what will be there? In the single phase AC, what will be there? Right. Sir, this is DC. Forward return path only. In the single phase AC, one terminal, this is called as phase. This is called as neutral terminology, right? Whatever the circuit I have taken so far, here, this is phase, this is neutral, but no need to represent that. Okay, now three phase, that's why I'm representing all the things very much clearly now. But, sir, three phase AC, sir, phase 1, phase 2, phase 3, and neutral may be there, may not be there. What is it? Everything I'll tell you. Wait. Okay, sir, in this phase forward path, neutral return path, we can use the color coding where one red color, here one black color wire, like that they will use. In the DC also, positive, negative, positive, one color wire, negative. We can identify, means by looking at the wire only, which is phase, which is forward, which is return path, we can understand practically. But if you're coming to the corresponding three phase, how can we differentiate? How can we differentiate? See, all are forward only. All are forward. How can you differentiate these two? Here, one is one color, other is other color, no problem. But here, three are same phases, forward paths only. That's why this is the practical idea. All over the world, same color. Red color, red color insulation, red color wire will be there. Y, yellow color, red color, yellow color, blue color wires will be there. One is red and one is yellow and one is blue color. Like this, three types of wires will be there. Until I complete this entire thing, RYB only will take. That too, very much important terminology. So these were the simple terminology based topic. Okay. Now, so neutral point is always return path, but in the three phase system, may be there, may not be there also. So without neutral point, how will it be? I'll tell you. Okay, right now. So in this three phase system, how many connections are there? How many circuits are there? Instrumentation people, you need not to answer this because you don't know. Don't worry, listen carefully, you will understand. Electrical people, how many types of connections are there? Means what are those? 2, people are saying star delta, star delta, star delta. Okay. But I'm requesting every electrical engineer, don't say star and delta first. No. You should say in the three-phase system, what is the first type connection is balanced connection. Balanced source or balanced load. Source side speaking, balanced source. Load side speaking, balanced load. And second thing, you should say unbalanced. Right? What is it? I'll tell you. IN people kindly more keen observation. Balanced and unbalanced load. What do you mean by balanced? Means, first of all, each and every phase is there, no? Each and every phase is there, no? All those three phases must be displaced by 120 degrees with each other, because 360 degrees circle, 120, 120, 120, 360 degrees. Okay, then that system is called as balanced. Not only that, sir, each and every load impedance must be same, because AC system, three loads are there, three Z, all should be equal. Then that is called as what is magnitude only. What is it? Balanced system. And voltage magnitude is also same. Generally, if nothing is given, voltage is same only. And sir, voltage is same, impedance is also same, automatically current is also same. Then this circuit is called as balanced circuit, load is called as balanced load, source is called as balanced source. So far we have taken single phase supply. Now we are taking three-phase supply. That is what the point. Okay. And sir, what is unbalanced? What is unbalanced? If any one condition, anyone, no need to invalidation of all. No, if any one condition is failed, that is unbalanced. If any one condition is failed, that is unbalanced. Clear? Balanced connection, and this is unbalanced connection. Be clear here. When do we say unbalanced? Means if this is failed, unbalanced. If this alone is failed, unbalanced means anyone is failed. That is simply unbalanced. Now you should say, sir, in the balanced connection, what is it here? One is star connection, other one is delta connection. In this unbalanced also, star connection, delta connection. And in this star connection, what is it here? Three phase, three wire. What did I tell you? These are connections only. Three phase, four wire. Right? In delta, only three phase, three wire. In the star also, again, same thing. Three phase, three wire star, three phase, four wire star, but delta only three phase, three wire. People are getting doubt like, so delta, why only three phase? Everything I'll tell you. But this is simply introduction only, simply introduction. After that, I'll be taking so many things in the next class, no problem. Clear? I have not started the three phase. Don't ask any question related to three phase right now only. Tomorrow complete day, same topic will be continued. Three phase power will be concluding the measurement of power today. Tomorrow, total topic, including all types of questions and all. Don't worry. Right, one fun statement I'm giving here. See, if anyone is sleeping, I already told you, know, one student asked that 1 is equal to 2 plus 3, one thing happened, I told you, know, yes, in the same batch here, same story, but he has asked the question like, sir, I is divided into star and delta. How, sir? Current is divided into star and delta. How can you say it is wrong, sir? In this way, students are asking the doubts without listening the class. This is what the corresponding doubt here. So this is what you mean students may be sleeping or something, etc. On that day, one student asked that, sir, Hindi actually Hindi, mein, sir, how I right, how I can be divided to star and delta? Sir, wrong, sir. I got confused. What should I answer for this? See, it implies the connection, the connection. Immediately, what I told no, what I told him no, immediately I did not answer this. I have given no. Sir, wrong answer is divided to connection. How I asked him. Immediately, he got it. Okay, okay, sir, okay, okay. He left me. He left that place. If this is the case, this is balanced. If wrong is there, so how wrong connection is divided into two parts? Immediately he got realized that okay, sir, a balanced hoga na, right? Come on here. That is what only I gave you. That's what that's why I'm requesting everyone to listen the class, to listen the class. Clearly, if you listen, definitely zero doubts will be there. Whatever the word I'm speaking, if you listen carefully without thinking something else, zero doubts, 100% guarantee. But what is the problem? You know, if I say take plus means, if people leave it and why not minus, they will thinking. If you think like that, what is the importance of taking the plus symbol? Missing, complete topic is missing. So many doubts. That's why in my that way I'm not going very fast also. Step by step I'll go you. If I while I'm explaining, if you concentrate with 100% concentration, zero doubts will be there. Because plus is to be taken as plus is to be taken, take it for granted. Why? I'll explain later. Why not minus? I'll explain later. But what you do, plus is taken. So why not that? Immediate typing, you'll be missing something. So I don't lose anything at any cost. Take it for granted here. I don't lose anything. If you're asking irrelevant questions and all, I'll be losing something. I will not be lose anything. You will be the loser. That is what my main headache. If I will be the loser, I can manage from my side, but you will be the loser. That's not the main problem. That's why concentrate, concentrate. If the faculty is saying that, you need to answer. Today also, few people, I did not concentrate on the question. Sir, if that is there, what happens? I neglected those questions. If this is there, take it first. If this is not there, that will be taken later, right? That was step by step, step by step. Simply what you're doing now, if the faculty is explaining APPLE apple, you first know that. After that, you'll be going for ANT ant, BALL ball. Like that, you will study. While the teacher is explaining, if you're thinking B and something, etc., this will not be clear. This also will not be clear. Your subject is not good. Electrical branch is waste. Something will be into picture. That's why every time I'm saying that, listen the topic carefully. Still, okay, people got reduced actually. Those people typed in between the session, reduced, but still 2-3 people are continuously typing. Okay, those people also will be set right in future. No problem. Right. Now I'm stopping now only because you're asking so many doubts now. So actually 9:30, 9:40 minutes, it's a problem, right? For everyone. That's why I'm stopping here only. Yes, any doubts you can ask me now itself. Right. Okay, different question, not related to subject. Sir, my question is different between offline and deep learn. Okay. See, offline class means you need to come to the AS Academy. On the whiteboard in the classroom, we explain. That is offline, just like your college going, no, same thing. Everything on the whiteboard. Well, what I'm doing now, everything will be explained. But deep learn means it is mobile app, Android mobile app. Through the mobile app, through the mobile, recorded videos you can watch. Means Android mobile, some login details will be given to you. And through that means at whatever the time you require, you can watch all the electrical subject recorded videos. This is deep learn platform. Recently, last only we introduced this one. Deep learn means you can watch through the mobile phone. Yeah, Bhaskar. Yeah, Bhaskar and Ankur M. Kashyap. Sir, what did sir told regarding offline class, etc.? See, offline class means you need to come to the AS Academy. On the whiteboard, we explain. See, concept very good, very boring, etc., etc. Yes, but nowadays COVID situation is like this, so that The problem is continuing now within 2-3 months. If the COVID situation, everything is set right, if you get the permission from the government, because in one class 100 200 members will be sitting now, they may not be giving the permission. Colleges only, they are not getting the permission. If we get the permission, we'll come back to that, no need to worry. But as of now, no offline. As of now, break. Only online and deep learning platform is going on. So deep learning is better or online is better? See, if Tulasi, very good question, but I'm not pointing out you, general I'm giving. If you concentrate properly while you're watching the video, only watch the video, only listen the class, note it. Then deep learning is simple. Same way, while I'm explaining, faculty is explaining, only listening the class carefully, both are equally good. Both are equally good, no need to worry. Yes or no? Both are equally good in both the ways. Same type of exercise, everything will be same. No need to worry at all. Both are same. Both are same. But people say that, sir, mobile phone is very difficult. Few people are saying. Few people are saying, sir, mobile phone it is very convenient. That depends on student mentality. But this online live session, laptop you can use so that it will be convenient for few people. But few people are saying that, say, if laptop is used, I need to sit at one place only. I'm not into like the different people, different mentality. Both are equally good. There is no difference in the subject at all. That is your interest. Right. Sunil Wagner, you will study in the mission's point of view, network theory. What is exact meaning of power factor? Yes. Right. Abhishek, sir, I don't have any problem, but sometimes you go fast in English. Is it? Okay, if it is so, I will reduce my speed. English speed. Okay. Yeah, Z means impedance, sir. Pranjali. Yes, Z means impedance. Introduction I gave you. I'll tell you tomorrow. No problem. Yes, tomorrow people are asking general doubts. Means no doubt from the topic. Very good. Very good. Preparation strategy. Yeah, Dinesh, correct. Each are having different advantages. Offline, online. What is a deep learn? Different advantages. But finally, advantage only. Right. So not getting that competition environment of offline class. So say that's what. See, everyone knows that because in the offline, so many people you will see physically, you will in touch with that. So automatically competition will be increased. But right now we cannot do no. Yeah, we cannot come back from our home. Second wave is over. People are saying the third wave will be there. Second wave is not yet over completely. Third wave they are talking. That's why we cannot. That's why as of now, no alternative. So that kindly this is there. Utilize this. I'm requesting everyone try to utilize this properly. So will you please explain strategy of preparation? When to start practicing previous question after how many days? Okay. People are asking from so many days. No, as you are not asking today, so many technical questions. So I'm giving this general idea. See, suppose my subject is first subject for you, for example, for many people, measurement subject. Okay. One chapter. What is it? Basics over. Right? Error analysis also over. Basics of instruments are also over, and instruments are also over by yesterday. Today power, tomorrow power will be over. Like this, step by step I'm taking, right? At least after 2-3 chapters, right? Generally every day I'm completing all the classroom practice questions in the class itself. Means whatever the questions PDF uploaded in the OTS platform, that is done by me only. For sake of more practice, I'm solving all those. Okay. And after this, at least, right, these 4 chapters completed. Now you can go for previous questions. If these are available with you, previous questions you can solve. But chapter wise only you have to take. But even though you solve the previous questions, few questions from this or from this or from this chapter, you cannot answer. Don't worry. Few questions will be combination of error analysis, combination of energy, combination of error analysis and potential, like the different will be there. That's why whatever the questions you are able to answer from the topics which are taken by me in the class, solve those. If any question is new terminology is there, think simply, that will be coming later. People are asking hardwire instrument, that will be coming later. Don't worry, everything will be given. This is the way. One thing. Second thing here, in my class itself I'm revising so many times. According to my knowledge, I'm revising so many times after the class. Means daily 4 hours class is there. Of course, 3.5 hours class, break and doubt session is a 4 hours class for approximately. After the class, 1 hour is sufficient to revise this entire thing clearly. Okay, 2 hours for example, 2 hours. After this 2 hours, one day class, right? Or 3 4 chapters over, no, at least from tomorrow onwards, all these 4 chapters you need to make short notes. You need to make short notes such that total subject should not cross 20 pages, not 20 papers, sir. 20 pages means page will be like this, no, page 1, page 2, it's a paper, 20 sides, not more, means 10 papers only the short notes. How means, if you're writing one line in the short notes, by looking at that one line, all the concept, everything must be recollected by you. That's why by looking at the notes, copying short notes, not like that. By preparing the entire subject clearly, then you need to prepare the short notes. If you see the short notes, total subject must be complete, must be revised in that way. Short note mean not very lengthy, complete 5 6 line notes people are writing. No, only gunshot points. If you see that point, yes, total 5 6 lines of statement should be able to revise. That's what the point. Yeah, actually, few people message me regarding what is that book. Actually, the book is almost 150 MB or 100 MB plus. It seems WhatsApp I cannot send. That's why I'm keeping my in my Google Drive. I'll be giving the link tomorrow in the class. I'll give my Google. What is that? Sorry, yeah, Google Drive. I will give the link of that entire thing. You can take that book. That is very high size, only very bigger size one. That's why I'm not able to send it. See, very good. Abhijit, right? Jack Naga Vinita, right? Good question. Actually, this is the question will continuously kill your what is that thinking and all. What is it? General question. Yes, very good. Sir, current kills or old age kills person when subjected to shock? Very good question. Throughout the BTech, this is very important doubt will be continued by everyone, right? Current kills or old age kills? Very simple. Whatever flows through the body that will give the shock, not kills actually, gives a shock. Always be clear, current only, not the voltage. Current will give the shock, not voltage. Suppose I'm touching the 230 volt wire. I'm very lean. You can understand in the figure, right? I'm very lean. Means flesh is very less. Okay. Suppose if I'm touching the 230 volts wire, I'm getting some shock, some effect. Suppose very fat person, full of flesh and full of water will be there. No, if that person is touching same 230 volt, same line, he will get more sensation. Why? 230, 230 same, but my body resistance and my body means approximately body resistance are different. Therefore, less current may be flowing, more current may be flowing. Based on that flow, generally we get the sensation. That's what the point. Actually, strictly speaking, current, but actually we say because of both also we say generally, but strictly speaking, current only gives a shock generally. And Abhijit, see, I told you average range of error or average range of error, both will be same in the practical idea. In the AK Sagane, maximum minus minimum is given, but next step, average error by 2 only. But in the examination, our maximum minus minimum by 2 only the answer. Okay. What basics should be learned? Yeah, this is very important point here. People are asking that. See, I don't know whether you know it or not. Basic electrical engineering textbook is there. Which textbook? That is diploma textbook. Diploma textbook. So we are BTech students. Don't feel bad. You're BTech only, but follow this textbook. Whatever the book available in your state, respective states, you follow that because state to state authors are different. So therefore, you can follow that. No problem. Basic electrical engineering, only diploma, not other textbooks. Diploma course textbook only. Other universally few books are there. In that again, highly standard. That's why purely polytechnic basic electrical engineering. One textbook is a follow that. Those who are belonging to Telugu plays, I know Telugu plays, I know the author, that is Rajalingam, M. Rajalingam. But other states, I don't know the respective authors, can you don't mind, you get your own book, but not the general book. BTech textbook, sorry, diploma textbook only get it. But those who are Telugu people, yes, in our Telugu state, this is famous book in Telugu state, this one. But other people, all diploma books are equally good, no problem. But diploma book only you have to take to get the fundamentals. People are asking, sir, which books must be followed to have the basics cover? Means this one. Sir, for permanent, what is the capacity of that? Whether it is maximum for the circuit? Which one, Bhavani? Magnet. One second, there is your question. There is a message. Boy, can you repeat your question? Which magnet is? Yeah, VK is also good, but VK is a little bit highly standard. That is useful for BTech also, VK. That's what. See, for measurement point of view, I'm giving the guarantee. Follow my class notes, follow my class questions. What are the questions are available with you, and previous questions more than enough. Textbook is need not to, but still people are asking, that's I'm giving that. Permanent magnet, what is generally using capacity in a circuit? See, that depends on 0 to 10 ampere or 0 to 15 ampere or 0 to 100 volt, etc. That depends on that capacity. Means 0 to 100 means how much flux is required. In that way, they will design here. That's why capacity wise, don't worry. That will be taken care by them according to the requirement. Right. Vishnu, I told you why current coil split into two coils in EMMC. I told you in yesterday's class, kindly go to that video. Right. And one more people. Sir, can you teach network theory for our batch? No, yeah. In the online live class, I'm taking only measurements only. Sir, in labs, meter should be placed in horizontal position only, sir. No, yeah. In the laboratory, you can place horizontal or vertical because spring control. Right. Sanjay Kalaskar, no, I'm not going to teach. Only measurements I'm teaching. In offline, so many places, no, Delhi, Calcutta, like that, so many places, no, Patna, Lucknow, Bhopal, like that, I used to teach. But here, everything is one batch only, no, yeah, like that, only measurements. Right, okay. One thing, sir, small I generally in the AC, capital I generally in the DC. This is a general idea that you study in the network theory, no problem. Right. Pawan Kumar, unmute from your side.
Sir, good evening, sir.
Yeah, good evening. Good evening. Tell me.
Sir, మీరు MC షార్ట్ LC షార్ట్ చెప్పారు కదా సార్.
Yeah.
ఇప్పుడు మనకి వాట్ మీటర్స్ ల్యాబ్ లో UPF LPF 2 డిఫరెంట్ వాట్ మీటర్స్ ఉంటాయి. మరి ఇప్పుడు మనం MC షార్ట్ ని LC షార్ట్ గా చేసి UPF పవర్ వాట్ మీటర్ ని LPF గా వాడుకోవచ్చా సార్?
అది మీకు రేపు చెప్తాను. 2 వాట్ మీటర్ మెథడ్ లో క్లియర్ గా వస్తుంది. ఆ తర్వాత కూడా నార్మల్ వాట్ మీటర్ ని LC షార్ట్ చేస్తే LPF లాగా వాడుకోవచ్చు. కాకపోతే దాంట్లో ఒక చిన్న ప్రాబ్లం ఉంటుంది. అప్పుడు మళ్ళీ LPF వాట్ మీటర్ రేపు చెప్తాను. రేపు క్లారిటీ వచ్చేస్తుంది మీకు, టెన్షన్ లేదు.
ఓకే సార్. నెక్స్ట్ ఇంకా ల్యాబ్స్ లో మనకి స్కేల్ లోనే 2 వాల్యూస్ ఉంటాయి. లైక్
Okay.
0 to 300 పైన 600.
Got it. Simple.
Ah.
Very simple. And ranges. See, other people also listen. 0 to 30 in your laboratory. 0 to 60 will be there. Simply, a single device means with less cost, 2 ranges they are giving. With less cost, they are giving 2 ranges. That's why on top side, one is neutral will be there. One is 30 will be there. One is 60 will be there. Means indirectly 2 ranges in the one device. 2 ranges will be given only for getting more and more ranges in single device. Means less cost. Suppose 0 to 30 separately you are taking. 0 to 60 separately you are taking. This is 2000 rupees approximately. This is 2000 rupees apart. 4000. No. Why? Means to reduce the cost, we are asking them to 1 meter with 30, 60, 90 like that. This cost will be 2200 only. That's what the point. If you are connecting this one and this one, means upper scale you have to concentrate. If you are connecting this and this, lower scale means in one device, 2 circuit. Just like your double cage induction motor will be there. No, same thing.
సార్ అంటే ఇప్పుడు మనం 30 కనెక్ట్ చేసాం అనుకోండి,
Yeah.
అప్పుడు మల్టిప్లైయింగ్ ఫ్యాక్టర్ ఎలా తీసుకోవాలి? అదే
Ah.
డౌట్ ఉంటుంది సార్.
లేదు మీరు అడిగే దేనికి? వాట్ మీటర్ కా నార్మల్ ఆమ్మీటర్ వోల్ట్ మీటర్?
ఆమ్మీటర్ కి వోల్ట్ మీటర్ సార్.
ఆమ్మీటర్ వోల్ట్ మీటర్ మల్టిప్లై ఫ్యాక్టర్ ఏముంటుంది?
ఉండదు సార్.
ఉండదు. ఎందుకంటే 30 యు ఆర్ టేకింగ్ 30 మీన్స్ ఈ స్కేల్ ఇక్కడ చూపించాను అనుకోండి 15 తీసుకుంటారు. అదే 60 అనుకోండి ఇక్కడ చూపిస్తే 30 తీసుకో డైరెక్ట్ గా. మల్టిప్లై ఫ్యాక్టర్ ఉండదు.
ఉండదు సార్. ఓకే. వాట్ మీటర్ అయితే సార్?
వాట్ మీటర్ కి అయితే దాంట్లో కనెక్షన్స్ ఉంటాయి అన్నమాట. 2 రేంజెస్ ఉంటాయి వాట్ మీటర్ లో. ఇక్కడ ఏంటి 300 వాట్స్ అంటారు, 600 వాట్స్ అంటారు. అయితే అప్పుడు కూడా కాయిల్స్ ఎలా కనెక్ట్ చేస్తారు? దీనిపైన C1 C2 P1 P2 అని ఇస్తారు. అప్పుడు మీకు ఎన్నికల ఫిగర్ ఇస్తారు అనమాట. ఆ ఫిగర్ ని బట్టి చెప్పొచ్చు మనం. ఇలా కనెక్షన్ చేసి ఉంటే మల్టిప్లై ఫ్యాక్టర్ 2 అంటారు. ఇలా కనెక్షన్ చేసి ఉంటే మల్టిప్లై 4 అంటారు. అంటే ఒక డివైస్ లోనే ఎక్కువ రేంజెస్ రావడానికి ఇవన్నీ వాడతారు అనమాట. అది పాయింట్.
ఓకే ఓకే సార్, థ్యాంక్ యూ సార్.
మీరు ఒక నిమిషం, ఎవరు మీరు? ఒక్క నిమిషం. నేమ్ పవన్. యా, మీరు పర్సూయింగ్ బీటెక్?
ఎస్ సార్. అవును సార్.
ఏ ఇయర్?
డిప్లొమా సెకండ్ ఇయర్ సార్.
ఇప్పుడు సెకండ్ ఇయర్ ఉన్నారు. సో నెక్స్ట్ ఇయర్ మీరు ల్యాబ్ లోకి వెళ్తారు కాబట్టి జాగ్రత్త, కంపల్సరీగా వాట్ మీటర్ చూసి వెనకాల ఒకసారి తిప్పి చూస్తే ఫిగర్ ఇస్తారు వాళ్ళు.
ఓకే సార్.
C1 C2 P ఒక్కసారి జాగ్రత్త చూడండి, మీకు క్లారిటీ వచ్చేస్తుంది.
ఓకే ఓకే సార్.
అది మిస్ చేయొద్దు, పక్కగా చూడండి. 2 తీసుకోండి, 4 తీసుకోండి, బ్లైండ్ గా వినొద్దు. మీరు ఒక్కసారి చూస్తే జస్ట్ ఇట్లా ఒక 2 నిమిషాలు చూసి మీకు అర్థమైపోతుంది. నేను ఎందుకు చెప్పట్లేదు క్లారిటీ అంటే ఆ కనెక్షన్ బేస్ చేసుకుని ఇస్తారనమాట. అది
ఓకే ఓకే సార్.
సార్
ఎస్
సార్, మనము లాబొరేటరీలో 3 ఫేజ్ లోడ్ యూజ్ చేస్తాం కదా సార్. అప్పుడు మోర్ కరెంట్ అనేది ఉంటది కదా సార్. అప్పుడు విఏకి ఏవికి మెథడ్ లో ఎట్లా అప్లికబుల్ అవుతుంది సార్?
చూడండి, 3 ఫేజ్ అనగానే హై అని ఎలా చెప్తున్నారు మీరు?
సార్ 415 వోల్ట్స్ ఉంటుంది కాబట్టి అక్కడ మెన్షన్ చేశారు కదా సార్.
415 వోల్ట్ ఉంది. రెసిస్టెన్స్ గనక 1000 ఓం ప్లేస్ చేస్తాము, 2000 ఓం, 4000 ఓం, 5000 ప్లేస్ చేస్తే కరెంట్ తక్కువే కదా. అందుకని సింపుల్ గా మన లాబొరేటరీలో యూజ్ చేసే ఏ లోడ్ అయినా సరే హై రెసిస్టివ్ లోడే, లో కరెంట్ లోడే. ఒక మీ డౌట్ ఏంటంటే రెసిస్టెన్స్ ఇలా ఉందండి, రైట్? ఒక రెసిస్టెన్స్ ఉంది, ఇక్కడ వీల్స్ ఉన్నాయి, ఒక 1 2 3 4 స్విచెస్ ఉన్నాయి. ఈ స్విచ్ ఆన్ చేశారు, ఆన్ చేయగానే ఎంత కరెంట్ వస్తుంది? 1 ఆంపియర్ కరెంట్ వస్తుంది. ఇది కూడా యాడ్ చేసరికి యాడ్ అయిపోతుంది 2 ఆంపియర్స్. అలా టోటల్ అదే చెప్తాను, ఎంత లోడ్ యాడ్ చేసినా కూడా మీకు 10 ఆంపియర్స్ కంటే ఎక్కువ యూజ్ చేయమని లాబొరేటరీలో. ఈ 10 ఆంపియర్స్ ఏమంటాం మనం అంటే లో కరెంట్. ఇది 3 ఫేజ్ లోడే. బట్ ఆ సర్క్యూట్ ఎలా డిజైన్ చేస్తున్నారు? 415 వోల్ట్స్ కి ఈ రెసిస్టెన్స్ ని ప్రాపర్ గా డిజైన్ చేసి కరెంట్ ని 10 ఆంపియర్స్ కి లేదా 13, అంటే మీ లాబొరేటరీలో 13 కూడా యూజ్ చేయమనం. 13 దగ్గరకు రాగానే స్మోక్ వచ్చేస్తుంది, పొగలు వచ్చేస్తుంటాయి, ఆపేస్తాం. అంటే 10 ఆంపియర్స్ వరకు యూజ్ చేస్తాం. అందుకని 3 ఫేజ్ అనగానే ఎక్కువ లోడ్ అని కాదు, ఎక్కువ కరెంట్ అని కాదండి. 3 ఫేజ్ లో కూడా ఈ రెసిస్టెన్స్ ని బట్టి కరెంట్ డిజైన్ చేస్తాం. సో లాబొరేటరీలో డెఫినెట్ గా లో కరెంట్ అప్లికేషన్ మన కాలేజీలో. అందుకని జనరల్ గా ఎంసీ షార్ట్ యూజ్ చేస్తాం.
ఎల్సీ ఏ కేసెస్ లో యూజ్ చేస్తాం కదా సార్?
ఏంటమ్మా?
ఎల్సీ ఏ కేసెస్ లో యూజ్ చేస్తాం సార్? ఎల్సీ షార్ట్.
ఎల్సీ అనేది ఇక్కడ అంటే ఓపెన్ సర్క్యూట్ టెస్ట్ లో, ఓసీ టెస్ట్ లో, ట్రాన్స్ఫార్మర్ లో, లేదు అంటే ఇండక్షన్ మోటార్ లో నో లోడ్ టెస్ట్ లో ఎల్సీ యూజ్ చేస్తాం. అది దానికి సంబంధించిన కంటిన్యూషన్ టాపిక్ అంతా 3 ఫేజ్ పవర్ మెజర్ రేపు టాపిక్ లో 2 వాట్ మీటర్ అక్కడ మీకు ఇంకో క్లారిటీ ఇస్తాం, అప్పుడు మీకు డౌట్ క్లారిఫై అవుతుంది. సింపుల్ లాజిక్ ఏంటంటే పవర్ ఫ్యాక్టర్ తక్కువ ఉంటే ఎల్సీ కనెక్షన్, పవర్ ఫ్యాక్టర్ బెటర్ గా ఉంటే ఎంసీ కనెక్షన్. అది సింపుల్ పాయింట్. అంటే ఏమంటామంటే ఓపెన్ సర్క్యూట్ లో పవర్ ఫ్యాక్టర్ తక్కువ అంటాను, ఓపెన్ సర్క్యూట్ కండిషన్ సెల్ఫ్ ఇస్ లో పవర్ ఫ్యాక్టర్ కండిషన్ అంటాం అన్నమాట. అది పాయింట్.
ఓకే సార్.
మీరే కదమ్మా ల్యాబొరేటరీలో కనెక్షన్ నేనే ఇచ్చాను మెసేజ్ పెట్టారు.
సార్ ఎంసీ షార్ట్ చేస్తాం సార్ ల్యాబొరేటరీ మెజర్మెంట్ ల్యాబ్ లో చేసినప్పుడు అయితే ఎంసీఏ చేసాం సార్ వాట్ మీటర్ కి.
అదే అంటాను, ఎంసీనే షార్ట్ చేస్తాము.
అది ఎల్సీ మెజర్మెంట్ లో చేసినట్టు గుర్తుకులేదు సార్, అందుకనేసి
నేను రేపు గుర్తు చేస్తాను ఆ టాపిక్ ని, నో ప్రాబ్లం. ఎందుకంటే ఒక ఎక్స్పెరిమెంట్ ఇండక్షన్ మోటార్ సర్కిల్ డయాగ్రామ్ వేసారమ్మా? ఇండక్షన్ సర్కిల్ డయాగ్రామ్ వేసారా? ఇండక్షన్ మోటార్ అయిపోయిందా మీకు బీటెక్ లో?
అంటే వాళ్ళు ఇచ్చింది డయాగ్రామ్స్ వేసుకున్నాం సార్, అండ్ కనెక్షన్స్ అనేది డయాగ్రామ్ యూజ్ చేసి చేసాం.
అది మీకు రేపు క్లారిటీ అంటే కొంచెం జనరల్ గా మీకు కదండి, ఏ స్టూడెంట్ కి కూడా ఇండక్షన్ మోటార్లు ఇది చేసామని గుర్తు ఉండదు జనరల్ గా. అది నేను గుర్తు చేస్తాను, నో ప్రాబ్లం. ఏం చేస్తాం ఇండక్షన్ మోటార్లు
అంటే ఆల్మోస్ట్ మెజర్మెంట్ లో అయితే ఎంసీనే షార్ట్ చేశాను సార్.
మెజర్మెంట్
చేయలేదు సార్, అంటే మెషిన్స్ లో గానీ అప్పుడు చేసాం అనుకుంటా సార్ ఎల్సీ, అందుకని అడుగుతున్నాను సార్. దీంట్లో
అదే అంటున్నాను, మనం మెజర్మెంట్ లో ఎంసీనే వాడతాం. ఎందుకంటే లోడ్ తీసుకుంటాం కాబట్టి హై రిస్ట్ లోడ్ తీసుకుంటాము. ల్యాబొరేటరీ మొత్తంలో మెజర్మెంట్ ల్యాబ్ అంతా ఎంసీనే, మిషన్స్ ల్యాబ్ కూడా మొత్తం ఎంసీనే. ఒక 2 ప్లేసెస్ లో తప్పిస్తే అది ట్రాన్స్ఫార్మర్ ఓసీ టెస్ట్ లో అండ్ ఇండక్షన్ మోటార్ నో లోడ్ టెస్ట్ లో మాత్రమే. అందుకే చెప్తున్నాను, ఆల్ ద థియరీస్ అన్ని కూడా ఎంసీ షార్ట్ లోనే యూజ్ చేస్తాము. అన్డౌట్ అండి, మీకు డౌట్ అవసరం లేదు. కానీ ఎల్స్ ఎక్కడ చూసి మీరు మర్చిపోయి అంటారు కదా, ప్రాబ్లం లేదు, రేపు నేను గుర్తు చేస్తాను. ఒక ఎక్స్పెరిమెంట్ ఉంది, ఆ ఎక్స్పెరిమెంట్ నేను తీసుకోవాలి ఇక్కడ నా క్లాస్ లో తీసుకుని మీకు కాన్సెప్ట్ ఎక్స్ప్లెయిన్ చేస్తాను క్లియర్ గా, ప్రాబ్లం లేదు.
సార్ ఇంకొక డౌట్ సార్, మనం వోల్ట్ మీటర్ లో కానీ యామ్మీటర్ లో కానీ ఏ కనెక్షన్స్ ఇచ్చినా సరే కానీ ఇంత రేంజ్ వరకే కరెంట్ కానీ వోల్టేజ్ కానీ వస్తుంది అని చెప్పేసి మెన్షన్ చేస్తాడు కదా సార్ బ్యాక్ సైడ్. అది ఎలా మెజర్ చేసి అలా కనెక్ట్ చేస్తారు సార్?
అంటే అదే చెప్పాను, అంటే మీరు ఒకటి గుర్తుందమ్మా, స్టాండర్డ్ అన్నాను, గుర్తుందా? స్టాండర్డ్స్, ప్రైమరీ స్టాండర్డ్ చెప్పాను స్టార్టింగ్ లో. అంటే వాళ్ళు ఇన్స్ట్రుమెంట్ డిజైన్ చేసేటప్పుడు రైట్, కస్టమర్ కి 0 to 10 కావాలి, అవునా? అయితే 0 to 10 వరకు క్యారీ చేయడానికి కాయిల్ యొక్క థిక్నెస్ ఎంత ఉండాలి, కాయిల్ డైమెన్షన్ ఎలా ఉండాలి, దాంట్లో స్ప్రింగ్ థిక్నెస్ ఎలా ఉండాలి, అవన్నీ కూడా మ్యాథమెటికల్ ఎక్స్పెరిమెంటల్ గా టెస్ట్ చేసి ఫైనల్ గా ఏం చేస్తారంటే 1 ఆంపియర్ ఇచ్చి చూస్తారు. 1 ఆంపియర్ ఎక్కడ తీసుకుంటారు? ప్రైమరీ స్టాండర్డ్ నుంచి తీసుకొని ఓకే 1 ఆంపియర్ ప్రాపర్ గా వస్తుంది. 10 కదండి, 10 కూడా ఇచ్చి చూస్తారు, ఓకే పాయింట్ ఇలా వస్తుంది. ఆ విధంగా ఎక్స్పెరిమెంట్ చేసేటప్పుడు నోన్ వాల్యూ, అంటే ఇన్స్ట్రుమెంట్ డిజైన్ చేసేటప్పుడు నోన్ వాల్యూ తీసుకొని దీనికి అప్లై చేసి పాయింటర్ మూమెంట్ అబ్జర్వ్ చేస్తూ డిజైన్ చేస్తారు. సింపుల్ అండి, ఒక సింపుల్ లాగా చెప్తాను, డోంట్ మైండ్. నార్మల్ ఇఫ్ యు ఆర్ గోయింగ్ టు టైలర్ షాప్, దే విల్ స్టిచ్ అవర్ డ్రెస్సెస్, రైట్? హౌ డు దే నో దిస్ ఈజ్ మై హ్యాండ్ సైజ్ ఎట్సెట్రా ఎట్సెట్రా? అంటే ఒక నోన్ టేప్ తీసుకొని మన బాడీ మెజర్మెంట్ తీసుకొని, అది కూడా సేమ్ అంతే. అంటే ఒక నోన్ వాల్యూ స్టాండర్డ్ తీసుకుని ఇన్స్ట్రుమెంట్ లో ఒక స్ప్రింగ్ ఇలా తీసుకుంటారు, ఒక స్ప్రింగ్ ఇలా తీసుకుని రెండింటిని చూస్తారు, ఓకే ఏది పర్ఫెక్ట్ గా వస్తుంది దానికి, ఆ విధంగా. అంటే అందుకని యాక్చువల్ గా మీరు ఎక్కడ చదువుతున్నారమ్మా?
సార్ రీసెంట్లీ అయిపోయింది సార్.
అయిపోయింది బీటెక్ ఎక్కడ?
నల్లమల్ల రెడ్డి ఇంజనీరింగ్ కాలేజ్.
నల్లమల్ల, ఓకే, జేఎన్టీయు.
ఎస్ సార్.
అయితే మరి జేఎన్టీలో మిషన్ డిజైన్ సబ్జెక్ట్ లేదు. మిషన్ డిజైన్ సబ్జెక్ట్ మన ఎలక్ట్రికల్ వాళ్ళకి వెరీ వెరీ ఇంపార్టెంట్ యాక్చువల్. ఆ సబ్జెక్ట్ మీకు అంటే మామూలుగా జేఎన్టీ యూనివర్సిటీలో ఓయూలో ఉందంటే, ఇది చదివితే అప్పుడు మనకు తెలుస్తుందంటే నాకు ఇంత అవుట్పుట్, మీకు డిసి మిషన్ ఏమంటారంటే నాకు 20 kW అవుట్పుట్ పవర్ రావాలి, డిసి మిషన్ డిజైన్ చేయండి. దాంట్లో మీరు ఫ్లక్స్ డెన్సిటీ ఎంత ఉండాలి, కాయిల్ లెంత్ ఎంత ఉండాలి, ఎన్ని నెంబర్ ఆఫ్ టర్న్స్ అంత ఎనాలిసిస్ చేస్తారు. మన ప్రాబ్లం ఏంటంటే మన దగ్గర ఉన్న యూనివర్సిటీస్ లో జనరల్ గా మిషన్ డిజైన్ లేదు. అక్కడ ఇవన్నీ చేస్తాం అనమాట. అంటే ఒక లెంత్ ఇంత తీసుకుంటే ఇంత వస్తుంది, లెంత్ ఇక్కడి నుంచి ఇంత తీసుకుంటే ఇంత వస్తుంది, ఆ విధంగా డిజైన్ చేస్తాం. అందుకని నోన్ వాల్యూ తీసుకుని మనం టెస్ట్ చేస్తూ తీసుకుంటాం. అది పాయింట్.
సార్ మనకి హౌస్ హోల్డర్ నుంచి అంటే సప్లై వస్తుంది కదా సార్ హోమ్ కి. అప్పుడు 415 వోల్ట్స్ వస్తుంది కదా సార్, అంటే పవర్ 230 ఏనా సార్?
230 వస్తుంది. ఓకే, యా, పర్లేదు. ఎలక్ట్రికల్ వాళ్ళకి డౌట్లు చాలా కామన్. మాకు కూడా బీటెక్ అయిపోయిన తర్వాత ఇలాంటి డౌట్లు క్లారిఫై అవ్వలేదు. టెన్షన్ పడొద్దు, సిల్లీ క్వశ్చన్ ఏమి హెసిటేట్ అవ్వద్దు. జాగ్రత్త చూడండి. మీకు స్ట్రీట్ పైన అపార్ట్మెంట్ అయితే అపార్ట్మెంట్ బయట, నార్మల్ హౌస్ అయితే స్ట్రీట్ బయట ట్రాన్స్ఫార్మర్ ఉంటుంది. ఈ ట్రాన్స్ఫార్మర్ నుండి 3 వైర్స్ వస్తాయి. ఆర్వైబి ప్లస్ న్యూట్రల్ కూడా వస్తుంది. అంటే ఏదో ఒక గల్లీలో చివరిలో ఉంటుంది ట్రాన్స్ఫార్మర్. అక్కడ నుండి వచ్చేసి చూడండి, ఆర్ వైర్ ఇచ్చేసి న్యూట్రల్ వైర్ ఒక 10 హౌసెస్ కి. ఇది హౌస్ 1, హౌస్ 2 ఇలా ఇస్తారు. ఎంత వస్తుంది? ఇది 3 ఫేజ్ 415, బట్ ఏంటి ఫేజ్ నుండి సింగిల్ ఫేజ్ వచ్చేసి 230. ఇదంతా ఒక స్ట్రీట్ అనుకోండి, ఒక సైడ్. ఇంకోటి ఏం చేస్తారు, వై ఫేజ్ తీసుకొని న్యూట్రల్ తీసుకొని మళ్ళీ కొన్ని హౌసెస్ కి ఇస్తారు. అందుకే ఒక్కోసారి మన ఎదురింట్లో పవర్ ఉంటుంది, మన ఇంట్లో పవర్ పోతుంది, అనగానే మనం తెలియకుండానే ఆ ఫేజ్ వేరే అంటాం. ఇది అన్నమాట. ఇక్కడ ఆర్ ఫేజ్ ప్రాబ్లం ఉంది అనుకోండి, అప్పుడు ఏమవుతుంది, ఈ రో అంతా పవర్ కట్, ఈ రో అంతా పవర్ ఉంటుంది. ఇక్కడ ఏదో రిపేర్ చేస్తారు, మళ్ళీ మనకి ఇచ్చేస్తారు. అది పాయింట్. అంటే ట్రాన్స్ఫార్మర్ దగ్గర 3 ఫేజే, మనకు వచ్చేది సింగిల్ ఫేజ్. అందుకే మీరు స్ట్రీట్ బయట వైర్ చూస్తుంటే పోల్ ఉంటుంది కదా, అక్కడ ఎన్ని ఉంటాయి? 4 వైర్స్ ఉంటాయి. 3 ఫేజెస్ 1 న్యూట్రల్. మీరు కరెక్ట్ గా అబ్జర్వ్ చేస్తే ఒక ఫేజ్ ఒక న్యూట్రల్, దాన్ని సర్వీస్ వైర్ అంటాం, ఒక బ్లాక్ కలర్ వైర్. దాంట్లో నుండి ఫేజ్ న్యూట్రల్ 230 వోల్ట్ వస్తుంది, 440 రాదు, ఎందుకంటే మన హౌస్ సింగిల్ ఫేజ్.
ఓకే సార్. సార్ ఇప్పుడు మన ఇంటికి వస్తుంది కదా సార్, అయితే అందులో హోల్డర్ లో మనము వోల్ట్ మీటర్ పెట్టి కరెంట్ పాస్ అవుతుందా ఎంత అనేది చెక్ చేసినప్పుడు అప్పుడు 230 వోల్ట్స్ వస్తుందా సార్? అంటే
డెఫినెట్ గా.
ఇప్పుడు రేంజ్ వోల్ట్ మీటర్ రేంజ్ అనేది తక్కువ ఉన్నప్పుడు అప్పుడు ఎట్లా చూపిస్తారు సార్?
తక్కువ మనం యూజ్ చేయకూడదు. అందుకే చెప్పాను నేను, మన సర్క్యూట్ రిక్వైర్మెంట్ తగ్గట్టుగా మనం మీటర్ ని సెలెక్ట్ చేసుకోవాలి. సర్క్యూట్ ఏంటి, 0 to 230 వోల్ట్ ఉంది. మీటర్ ఎలా ఉండాలి, అట్లీస్ట్ 240 250 రేంజ్ ఉంటేనే యూజ్ చేస్తాము. తక్కువ ఉంది అనుకోండి, మీటర్ కాలిపోతుంది కదా.
ఓకే సార్,
అర్థమైందా?
ఓకే సార్.
హలో,
ఎస్ సార్.
అది ఇంకోటి, మన 230 ఎగ్జాక్ట్ ఉందండి. 230 +or-10 టాలరెన్స్ కంపల్సరీ. మీకు 220 220 అలా, ఎందుకంటే అది కామన్ వేరియేషన్ ఉంటుంది అనమాట. బట్ 230 అంటాం ప్రాక్టికల్ గా.
ఓకే సార్,
రైట్?
ఎస్ సార్.
ఓకేనా?
ఓ సార్.
Hello, sir.
Yeah.
Sir, yes, sir. Good evening, sir.
Yeah, good evening.
Sir, how are you, sir?
Fine. Thank you. How are you?
Yes, sir. I'm very good, sir.
Yeah, tell me.
Sir, I have a doubt regarding this wattmeter EMMC, sir.
Yeah, tell me.
Sir, while I'm studying in college, I saw that error can be reduced by using that shunt capacitor to that series resistor, sir.
I will tell you that.
Similar to.
I will tell you that later.
Yeah, not now, sir. Yeah, okay, sir. Okay. No problem.
Yeah.
No, sir. Just I was remembering.
Yeah. That is there. Potential coil error reduced by capacitor. I'll tell you that later. No need to worry. All the topics will be covered.
Yeah, that's what I got struck in my mind. Okay,
No.
sir. Sir, one more thing, sir. Yeah. Sir, while you are explaining those errors, you have mentioned only 2 points now, sir. You went very fast. I couldn't write my notes.
Which one?
After deriving the correction factor and percentage error relations.
Yeah.
After that, you have mentioned some before this, sir. Before that. Yeah, conclusion. This only, sir.
Yeah.
Sir, please tell this one on the next page, only 2.
Come on, why? I spent lot of time.
Yeah, I understood, sir, but I didn't note it down, sir.
That's what. See, while designing, beta should be low. While designing, why I'm saying is beta, we cannot change it. Who can change? Manufacturer. Yeah. That's why I told you one point. Beta value must be lower to get less error. Beta is low, error will be less. Therefore, potential coil must be designed with low beta. That is, designed with low inductance. Low inductance means less reactance. Automatically, beta will be low. And while operating. While operating, we cannot change the beta, right? Operating means in the
Yes.
operator hand, which is there, phi is their power factor. That's why if the power factor angle is low, means phi is low, tan phi low, error will be low. Therefore, what is it? Here. So automatically power factor angle is low, then tan phi is low, or error will be low. Power factor angle should be low means power factor should be high. That's why I told one thing. In practical entire life, good power factor loads only we prefer it only.
Yeah, yes, sir. So next page, sir, please.
Simple examples. I
Yeah.
told you. This one next,
one, sir.
and this one is one next. After that,
Okay.
one common question again.
Okay, sir. From here I wrote, sir. I didn't write all this. Okay, sir.
Okay.
Thank you.
Okay.
Hello, sir.
Yeah.
Sir, my doubt is in error due to self-inductance, that topic, sir. Can you
Which doubt? Which
open
doubt here?
30F, sir? Can you open,
Huh?
sir? 30F.
30F. Yeah.
Sir, one page forward, sir.
One page forward.
Sir, no, sir, no, sir. I think 29, sir. Yes, sir.
Yeah.
Sir, I have understood mathematically that the measured power will be greater than the true power, sir.
Yeah.
But how to understand conceptually, sir, that extra power, which power is
Okay.
contributing to?
I got it. No worries, no worries. Yeah, this is $1 million question actually. Actually, power is not the extra power, how it is coming. Very simple. In the entire instrument, not only internal, external effect will be there, no? Yes or no?
Yes, sir.
Yeah. Due to this external power, under lagging load conditions, the external field will be aiding the internal field. Therefore, this field and this field will be added. It will show more than the value. Don't get confused like how extra power is not coming here. Simply here 2 is there. It will show 2.3 means extra force is produced. How the extra force will produce? Extra field. How do you get extra field? With the external addition, means with the help of lagging load condition, this nature itself is giving the corresponding extra magnetic field in that. That's why the resultant field will be increased, force will be increased from 2 to 2.3. But kindly don't get a confusion like how extra power is not coming, because this meter is not giving the power. This meter is measuring the power value. That's what. Under lagging load condition, the corresponding force will be more. Yes, it will be showing more than the value. That is the nature of the load. If you are keeping leading load means what? Good one. So therefore, it will be giving the less than that.
Okay, sir.
Don't think like power will come. Power will not come.
Okay, sir. Understood.
Right. Somashekar Reddy. Unmute from your side.
Sir, I
Yeah.
am Mubin, sir. Sir,
Yeah,
one
okay.
basic question I need to know. Sir, for an MI instrument, if
Mubin?
we give...
Mubin.
Yes,
Okay,
yes,
kindly
sir.
wait for 1 minute. Other person also waiting, so
Yeah,
that
no
I
problem.
because I clarified your doubt. No, just wait.
Yeah.
Yeah, tell me, Somashekar Reddy. Somashekar Reddy. Okay. Yeah, Mubin, you can unmute.
Yeah, yes, sir.
Yeah.
Sir, that in MI instruments, if we give current like 5 plus 7 sine omega t, which is having both DC and AC, then it measures RMS value only, no, sir?
Yes. See, actually,
I mean,
one thing you remember here. Actually, we should not say strictly DC plus AC. No, not DC plus AC. Right? How can you combine DC? But terminology, okay. But if you're going in depth, like so DC plus AC, it will actually see. This I'll explain the network theory. This is 5 amperes DC. This is 7. So 7 sine omega t. By the combination of these means, you need to understand that Here, so 1 second. I will draw this in the next page. How the waveform will be there, this and this will be combined, means phi is there, no, it will be shifted by phi like this. This value, whatever the shifted value is there, no, that will be shifted up, no, that is taken as phi magnitude up to this phi, up to this 7. Means throughout this entire thing, average value will be available like this. That's why even though it is still AC only, it measures RMS only. But for saying purpose, DC plus AC, okay. But how do we add DC plus AC? DC is there, AC is there. Why only RMS? So many headaches will be there. That's why it is not DC and AC. AC is shifted by 5 units. But I did not discuss all this with the network theory discussion. Now you are asked. Now you can ask your doubt.
This only, sir. It means what does the I'm asking. I want theoretical statement, sir. It reads RMS or anything else.
RMS only, definitely.
RMS.
MI means undoubtedly RMS only. I told one question today. 8 plus 7, something 8 plus 6.
Yeah.
Same thing.
Yeah, same. That's based on that only I got.
Yeah,
Sir.
same.
Okay.
Clear?
Yeah, clear, sir. Thank you.
Finally, all the people's doubts clarified today. Right. Okay, guys. Thank you, everyone. Good night. Tomorrow, same time.
Sir.
Yeah, who is this? Online.
సార్ ఒకసారి ప్రాక్టికల్ లో ఒకసారి అది చూపియరా సార్ వి ఫేస్ బై ZP ఎలా తీసుకున్నాను
V phase by ZP, na? Okay. Right. ఇది కదా? ఇది చూడండి. V phase supply voltage. ఎక్కడ అప్లై చేసామండి? పొటెన్షియల్ కాయిల్ కి. ఓకే అండి. అయితే పొటెన్షియల్ కాయిల్ లో ఎంత ఇంపెడెన్స్ ఉంది? R అండ్ R కలిపితే RP ఉంది. LP కూడా 0 అవ్వలేదు, ప్రాక్టికల్ కదా. అప్పుడు ఏమవుతుంది? వోల్టేజ్ బై టోటల్ అపోజిషన్. ఇది మాత్రం చూడండి మీరు. జస్ట్ 1 సెకండ్. హియర్ వోల్టేజ్ బై పొటెన్షియల్ కాయిల్, ఇది మాత్రం చూస్తే ఏమవుతుంది? పొటెన్షియల్ కాయిల్ వోల్టేజ్ బై RP ప్లస్ JXLP ZP. దట్స్ ఇట్స్ వెరీ సింపుల్. అదే ముందుకెళ్ళి చూపిస్తాను. దీంట్లో ఎల్పి లేదు, అప్పుడు ఏమవుతుంది? వి ఫేజ్ బై ఆర్పి మాత్రమే. అది సింపుల్. ఓకేనమ్మా?
సార్ ZP దాని కింద కేసులో RP అని రాసాను.
ZP
ని మళ్ళీ RP కేసు.
యా, ఓకే. ఇక ఈ ఫార్ములా చూడండి. కాస్ బీటా ఈక్వల్ ఆర్పి బై ZP కదండి. ZP ని ఇక్కడ తీసుకొచ్చేస్తే ఆర్పి బై కాస్ బీటా కదా.
ఓకే సార్.
ZP ఈక్వల్ టు ఆర్పి బై కాస్ బీటా ని న్యూమరేటర్ తీసుకెళ్ళాను అంతే. ఆర్పి బై కాస్ బీటా కదండి, డినామినేటర్ న్యూమరేటర్ కి తీసుకెళ్ళిపోయాను అంతే.
ఓకే సార్, అండర్స్టూడ్ సార్.
Sir.
Yeah.
Hello.
Sir, I have sent you a photo onto your WhatsApp number. Sir, in that, please open it.
Yeah, I'll talk to that. 1 second. Yeah, other people? Mubin, I'll come to you.
Sir.
Hello.
Sir, can we use the wattmeters in DC circuit?
Yeah, we can use.
Sir, how, sir?
Why? What's the
Still
doubt?
you are, sir, still you are saying only in AC circuits wattmeters used.
Or who told? Did I say that? No, I told that in the starting topic of today's only. What I told you? Here, one
Oh,
second.
AVN, VM method.
DC, EMMC already we have taken. This is the extra topic we are taking. Don't think that DC, already yesterday I proved no here. DC power management, EMMC already there. But new method in this we are taking. But in the AC, one and only one method, that is MC short and LC. That's what I have taken. But DC power is not measured by what? No, yeah. Already we have done. I told that statement clearly. Already EMMC we have taken over. New method I'm taking. But in this, why I'm taking this, MC short, LC short, we have not taken clearly step by step. No, that's why I have taken all this.
Okay, sir.
Somashekar Reddy, you're not speaking.
Sir.
Yeah.
Can I ask now, sir?
Yeah, now you can ask. Yeah.
Sir, I have sent a photo to your WhatsApp number.
Oh.
The question is based on MI voltmeter extension range.
1 second. Your number is 91217, that only?
Yes, sir. Yes, sir.
Yes.
Sir, below you can see that method I have solved by phasors. Can you see?
500 equal to VM plus VSC. I have taken as reference. Okay, VSC is in series. Why VSC you have taken in phase with I?
Sir, VM in phase with I, sir. Sir, that
No, you have
V-
taken VSC in phase with I, right?
yeah, yes, sir. VSC because it is a resistor, na, sir. A series
Arey,
resistor
come on.
only.
Okay, in this question, okay, RESC, right, okay. And then VM, yeah, lagging, okay. VM
It's
plus
lagging.
phi is equal to 500. VSC 100 RESC. Not exactly what you're missing, you know. I will check this procedure. I will not try this. The new process, something is missing that I'll let you know.
Okay, sir.
I'll let you
Sir,
know.
because while in diploma, I solved most of the problems by this method only. That's why I got
Yeah,
it.
yeah, you can do, but something small thing is missing. I'll let you know.
Okay, sir. Thank you very much.
Okay, guys. Tomorrow same time. Thank you.